What, sweetheart? What, sweetheart?
Blockchain technology is changing the world. Implementing blockchain technology will hugely impact our society in the future. There are, however, a series of hurdles to cross before it's accepted by mainstream consumers. After years of research and development, we have crossed the hurdles and finally solved the problems. Introducing ArcBlock, the new generation of Blockchain 3.0.
ArcBlock is designed for the Blockchain 3.0 age. We've done more than solve the fundamental problem facing blockchain technology today. We built a brand new infrastructures. ArcBlock provides framework and tools that help consumers to use the decentralized app just like today's web and mobile apps.
Blocklet is the core foundation for
Blockchain technology is changing the world. Implementing blockchain technology will hugely impact our society in the future. There are, however, a series of hurdles to cross before it's accepted by mainstream consumers. After years of research and development, we have crossed the hurdles and finally solved the problems. Introducing ArcBlock, the new generation of Blockchain 3.0.
ArcBlock is designed for the blockchain 3.0 age. We've done more than solve the fundamental problem facing blockchain technology today. We built a brand new infrastructures. ArcBlock provides framework and tools that help consumers to use the decentralized app, just like today's web and mobile apps.
Blocklet is the core foundation for ArcBlock and a high-level application protocol. It combined microservice architecture and serverless computing. Meanwhile, Blocklet can access any external data sources, which links both the computing methods of the upper and lower bound. ArcBlock uses these advantages to carry out smart contract and off-chain business logic, such as database for enterprise, certification for government, stock market, and medical records.
ArcBlock's design can be used to connect different blockchain protocols and platforms. Developers won't get locked in with one platform anymore.
The Open Chain Access Protocol provides an abstract layer for accessing underlying blockchains, enabling your application to work on different blockchains. Your applications can be freely switched instead of changing your business logic codes.
ArcBlock is born for Blockchain 3.0. I believe our platform makes the technology accessible for the people in their everyday life. It's essentially changing the world.
ArcBlock is designed to perform in cloud environment, which boosts performance and reduces the cost of blockchain. Our ultimate goal is to create a platform that offers user-friendly blockchain applications more for consumers, which in turn enables developers to focus more on the technology.
The ABT currency that we have issued allows a one-to-one mapping with ERC20. Developers get to use an advanced Ethereum ecosystem, as well as obtaining a high-performance and fully functional token economy service. Besides being a cryptocurrency, ABT can be used as a pass, such as user recognition, certificate, and document in the real world. We encourage more miners to join ArcBlock in order to get more tokens. With the help of the token, ArcBlock will become a service platform that constantly improves.
Blockchain started almost 10 years ago with Bitcoin, then slowly evolved into 2.0 projects like Ethereum. ArcBlock represents the third generation of blockchain projects and will elevate computing platforms for blockchain to the next level.
It is an ecosystem for developing decentralized applications. The ecosystem will evolve on its own. We are just here to ignite a new revolution.
Good morning. Morning. Good morning. Good morning. Hello? Welcome to day 2. Testing. Testing. 1. Be starting in about an hour and 20 minutes.
Blockchain technology is changing the world. Blockchain technology is changing the world. Implementing blockchain technology will hugely impact our society in the future. There are, however, a series of hurdles to cross before it's accepted by mainstream consumers. After years of research and development, we have crossed the hurdles and finally solved the problems. Introducing ArcBlock, the new generation of Blockchain 3.0.
ArcBlock is designed for the Blockchain 3.0 age. We've done more than solve the fundamental problem facing blockchain technology today. We built a brand new infrastructures. ArcBlock provides framework and tools that help consumers to use a decentralized app, just like today's web and mobile apps.
Blocklet is the core foundation for ArcBlock and a high-level application protocol. It combined microservice architecture and serverless computing. Meanwhile, Blocklet can access any external data sources, which links both the computing methods of the upper and lower bound. ArcBlock.
Hi everyone, my name is Zhang Zhenqiang, and I'm a front-end engineer of ArcBlock. And today I will demonstrate how to
Hello everyone, my name is Jonathan, and
Good morning. Thank you.
Blockchain technology is changing the world. Implementing blockchain technology will hugely impact our society in the future. There are, however, a series of hurdles to cross before it's accepted by mainstream consumers. After years of research and development, we have crossed the hurdles and finally solved the problems. Introducing ArcBlock, the new generation of Blockchain 3.0.
ArcBlock is designed for the Blockchain 3.0 age. We've done more than solve the fundamental problem facing blockchain technology today. We built a brand new infrastructures. ArcBlock provides framework and tools that help consumers to use a decentralized app, just like today's web and mobile apps.
Blocklet is the core foundation for ArcBlock and a high-level application protocol. It combined microservice architecture and serverless computing. Meanwhile, Blocklet can access any external data sources, which links both the computing methods of the upper and lower bound. ArcBlock uses these advantages to carry out smart contract and off-chain business logic, such as database for enterprise, certification for government, stock market, and medical records.
ArcBlock's design can be used to connect different blockchain protocols and platforms. Developers won't get locked in with one platform anymore.
The Open Chain Access Protocol provides an abstract layer for accessing underlying blockchains, enabling your application to work on.
Hi everyone, my name is Zhang Zhenqiang, and I'm a front-end engineer of ArcBlock. And today I will demonstrate how to deploy and install our ABT node to some different environments. And to deploy our environment is very easy. We have provided
How does this sound now? Better? Okay. Right, we are back. All right, everyone. Good morning, afternoon. Welcome back again to Devcon 2020. For those of you who were with us yesterday during day one, we thank you, of course. And for anyone who's just joining us, welcome. So yesterday was actually a pretty long and busy day. We want to give a quick shout out and a thank you to our partners and friends who joined the different sessions, looking at opportunities for developers and talking about blockchain, DApps, and everything in between. So yesterday, we also discussed the journey that ArcBlock has been on since late 2017 and how that vision is really now being fulfilled. We're focused on creating the best developer platform to create, deploy, and manage modern blockchain software. Of course, saying it's just one thing, but showing you is actually what we want to do here at DevCon 2020. We introduced several very important ArcBlock platform updates yesterday. We talked briefly about the new ABT node and what it can do for developers and app builders. We introduced Blocklets, our new marketplace, and the ability to have that option for one-click app installs that allow anyone to easily extend the features of your ArcBlock environment. An ABT node, allowing you essentially to pick and choose the things that you need for your project. This can include launching one or many blockchains that already support interoperability, or deploying our new DID Connect identity blocklet so you can run your own decentralized identity services. We even looked briefly at how you can create your own blocklets and deploy them in ArcBlock's decentralized marketplace. So to get started this morning, it's going to be less about talking and more about doing. So we're going to go in a slightly different direction. Today, we're going to let the code do the talking and let our platform speak for itself. So ArcBlock's engineers and some of our friends are going to lead several really great developer workshops showing you how to deploy and run ABT node, how to create and use and customize blocklets, as well as showing you from beginning to end how to build your own blockchain game using ArcBlock's blocklets and SDK. So let's go ahead and get started. Without further ado, this first session is going to look at how to deploy our ABT node and set it up using different environments and cloud providers. So let's go ahead and get started.
Hi everyone, my name is Zhang Zhenqiang, and today I will demonstrate how to deploy and install our ABT node to some different environments. And to deploy our environment is very easy. We have provided a command line tool to make the things easy, and we also make a Docker image, and so we can run Docker in more systems, and so we can also run Docker in some container services. And today I will demonstrate on these five platforms. And the first is my Mac OS, and then is with Docker on my Mac OS, and third I will deploy it on Hot Cloud. Hot Cloud is our partners YoupaiYun's container service, and then I will deploy on a cloud powered by OpenStack named Auro. Auro is spelled AURO. and at last, I will deploy it with our own node launcher. ABT node launcher is a blocklet, and I will show you later. And also our ABT node can run on macOS and Linux, but for some compatibilities reason, ABT node can't run on Windows just now. Oh, sorry, we can't run on Windows now. And first, let's see how to run our node on macOS. Because our command line tool and ABT node daemon, ABT node is developed by Node.js, So first we have to install Node.js in our computer, and then we have to install our abt node CLI. It's a command line tool to deploy the abt node, and I have installed Node.js and abt node CLI on my Mac, and so I will skip the two steps. If you guys are not familiar with Node.js and apt node CLI and npm, you can visit the docs, the official docs of Node.js. And with apt node CLI, we can initialize a configuration file and then start the apt node. Now let's see how to use our apt node CLI to create a configuration file. And to initialize the config file, we can use apt node init. We can check the init means. Init is to init a config file. So let's use init. And first we should set the apt node name, and I will change it with Devcon, and description, and the store data, the folder to store data, and I will use default tool, and set up IP because it's my own Mac, so I will use it local IP, and then port, and then the blocklet registry. The blocklet registry is used to fetch the blocklets and download blocklets. So we have to set it up. And at last, we have to set the config file to store the configs we just now set it. So we have initialized the configuration, and then let's use the command start. Okay, it's started successfully. Let's see that. Let's visit the address in the browser. Wait a minute. Okay, now we can see a setup page. We must first to set up the owner of the apt node, and we must set up it at the first time to access. And to set up the owner, we must use our apt wallet, and use our apt wallet to authorize. And more things about our apt wallet, my colleague will give a share on the Devcon. And if you guys have interested in it, you can follow our Devcon. Wait a minute and open my wallet to scan the QR code. Maybe slowly. Wait a minute. Okay. Okay. After set the owner, then we will check the name and the description information, and confirm that there is no error in it, and I will complete the setup. And now we have set up the node completely, and then let's go. Let's take a shot to the dashboard. Okay, this is dashboard, and the dashboard show many informations about the ABT node. Something about something like uptime, create, and storage information, and the DID, and the environment information like internal IP and other things. And then let's see the block class list page. The block class list page. List page is will list the installed block class, but we have not installed it. We have not installed any block class, so there is no block class here. And if we want to install block class, we can visit it. We can download it, install it on marketplace, and we can see about we can see some block class here. And now I will install a block class named blockchain manager. The blockchain manager is used to create a blockchain and manage the chains. Let's install it. Okay. We can see it in block class list, and then let's start it. Okay, we have started successfully, and now we can see a admin interface link in the visit column, and let's open it. Now we can create a chain in the admin page. Let's create. And before create a chain, we must first we must download the forgery list firstly. But it will download. It will download during the creation. And then we must set up the chain name, and I will set it default, and the token name and the token symbol. And also we can see it requires to create a moderator. The moderator is the administrator of the chain, and we can create a moderator by our ABT wallet too. Wait a minute, I will open my wallet. Okay, I have scanned and authorized. Okay, we have generated a moderator, and then let's create. Because just like I said, it will download the full release. We can download the progress here, and it may take seconds or just wait. Okay, it's downloaded, and let's see the chains. Okay, let's start it. The start progress will take about seconds because Forge need to initialize something. Wait a minute. Okay, we can see it's running now, and we can check out if the chain is running by visit the blockchain explorer. We can open it with this tab, and it will open a new tab in the browser. And this is a chain chain explorer created by the blockchain manager. We can see its address. Okay, and we can view the basic status of the chain, like blocks and the transactions and other things. Okay, okay, this is how to deploy and install our ABT node on Mac OS or other systems, or like other systems can also use the same method to install. And we also demonstrate how to use the blockchain manager blocklet to create a chain and manage the chain. And now let's stop the chain. Okay, we have stopped. Oh, I'm sorry. I mean stop the chain manager. Okay, this is how to install on macOS, and then let's see how to run with. And the Docker. If we use Docker, first we should pull down the image from Docker Hub, and with the command. Let's see how to because I have pulled it to my my local because it may take a long time, so I have downloaded it before. So I want to pull it again, and after pull the image, we will run the Docker to create a container. But how to run? We can check out the doc. The doc is on the Docker Hub. We can wait a minute. Let's check it in the Docker Hub and search ArcBlock ABT node. Oh, it's here, and open it. And we can see this is a page of the ArcBlock ABT node on the Docker Hub, and we can see the install command. The run command in the doc. And let's copy this command. And I will run the command in the terminal. Before run the command, we must modify the some parameters. First is a port map, and the ABT node is run on port 2029. So we just map the 2029 port, and then set the shared volume, and I will mount my local temp files, temp folder at Docker ABT node. And then we also need two environments. One is ABT node, and the ABT node domain. ABT node domain is used by the ABT node, and it's a IP or domain of the of the Docker service. So I will set it my local IP, and I will check what's my local IP. I will copy it. And then the port must be same as we just mapped, and it's 2029. And then the image ABT node, ArcBlock image name ArcBlock ABT node. And now let's try to run the command. Oh, sorry, I just used the port, so it can't be run at 2029. We changed it to 1000 and modified. Okay, it shows started. The container is started. Let's check it. use the container list. Okay, it started. Let's visit it in the browser, and with the local IP and with the port we just set it. Sorry, not 2029. Let's copy. And the port is forgot. 10000. Okay, we can see a new ABT node is deployed, and also at first access we must set the owner, and I will do the same thing with the previous one. Wait a minute, and open my wallet and to scan the QR code. Okay, I have authorized it. Okay, and we can see the description is contains a Docker keyword. In the container, we no need to set it manually to set the name and the description and the block registry, because it has been done by the container itself. It is the Docker image itself. We just to confirm the name and the description in the page and complete. And also let's take a tour of the dashboard. We have see the blocklet dashboard, and one thing we can see, the environment is in Docker. Yes, the site is running Docker. So this is how to run a Docker image. This is how to run the apt node with our Docker image, and we have run the apt node successfully with a container. And next, let's see how to deploy our deploy the Docker image to the hot cloud. Hot cloud is from Youpaiyun, and let's open hot cloud's website first. Wait a minute. Its domain, its website is hotcloud.com, and this is the homepage of the hot cloud, and I have logged in. So let's open the console directly, and in the console we can see a project list, and let's create a new project to click the create button, and select the resource pool, and we set to Hangzhou, and name the project. We will set the name with Devcon, and remark it with Devcon demo, and will not set the logo. Just use default image and confirm. Okay, we have created a project named Devcon, and let's enter the Devcon page, and we can see we'll first create a container service, and I will create a stateless service, and this is a stateless service selection, and named the service, and I will name it with apt node, and set the remark is apt node demo, and the access control I will keep it default and confirm. Okay, we have created a container service, and And the container service has a public domain. The public domain is a critical parameter to our ABT node, just like we just set it in the Docker at my Mac OS. So we'll copy it and we'll use it later. And then let's create a container instance. First, let's select a container. Let's select the Docker image, and one thing we should pay attention is we should upload our container, our Docker image to the hot cloud first, because the hot cloud will load the image from its hot clouds only. So for save our time, I have uploaded the ABT node image to the hot cloud before. So I just select the image and select the version with the latest, and set the instance count. We'll set it 1, and the CPU count is 1, and the memory 1, and set the port with a port that is difficult to that is different to others port. We'll set it 31888. Okay. This port is nothing. It's nothing. It's just set it randomly, and the instance strategy will keep it default. And the start command. Start command will use abt node command. Abt node start silent. A silent parameter means it will generate a configuration file automatically, and then set the keep live. The keep live parameter will keep the Docker run daemon, and then set the environment, process environment, and one is abt node domain. We have just set it in macOS Docker. I'm sorry, DOMAIN. Sorry. And its value is a public address. We just copied, so I just paste it. Oh, sorry. Oh, sorry. I forgot to paste it. Let's copy it again and create. I'm sorry, just lost a copy. Select Docker image and version and 1 and port 3188 and the command. Sorry, wait a minute. Now let's set it again. abt node DOMAIN, and the value is a public address, and then set abt node port, and its value is we just set it before and paste it, and we'll no need to set the mount folder, and the logs will print it in the standard output. So next, and we'll no need to confirm set the health checking, because it's just a demo. And now we can see the instance is running, and we can see the log. Or we can see the container is running. It started successfully, but before we can access it from public networks, we must map the port we just set it 31888 to the public. So let's configure set it here, the public address access, and we have to create a row and select the port we just we needed to map, and the this is a load protocol. We select TCP, and the port we just we should select 31888, the same as the port we mapped, and confirm. Okay, we just create a role to let our container can be accessed from the public. This role may be effective minutes later or seconds later. We just wait a minute, and now we can visit our container service with a public address and with a port. We just set 31888. Let's try. Okay. The port is effect. Wait a minute. The first visit will be do something to initialize. Okay, we saw this QR code again, and we just saw this QR code twice, so I no need to waste our time to explain it. Let's set the owner with our ABT node, with our ABT wallet. Wait a minute. I will scan the QR code. Okay, I have authorized it and confirm the basic settings, and I will not edit it and complete the setup. Okay, let's take a tour of the dashboard, and we can see we have just created in the whole cloud, and the Docker the environment is in Docker. So this is a whole process progress how to deploy our ABT node to the hot cloud, and it's just to with your mouse click and click. It's a simple operation, and it's easy to deployment to the hot cloud. And so let's continue to see the next environment, the Oro. Oro is powered by OpenStack, and first let's open the Oro's website. Wait a minute. Oro, and oh, I have logged in. This is the dashboard of the Oro, and let's open the cloud dashboard. And this is the dashboard of the of my cloud account, and this is basic information of my account. And then let's create an instance to deploy our ABT node. To create an instance, we just launch the instance, and the first step we should name the instance. We call it ABT node, and then we'll keep other settings as default. And next to select the source. The source will select from the image marketplace. So we will select Ubuntu, and we'll click this button to select. And next is the flavor. We'll select standard 2, and also click this button. And next we'll keep default. Next. The security group, we should map the some port to the public network, because because we need to make our ABT node can access from public network. So this I have mapped a pod range in the security graphs, and we'll click next. This KPI is my KPI is my max KPI. So later I can connect the instance from my Mac with SSH. Next, and then launch the instance. Wait a minute. Okay, we can see a building instance just tens of seconds. Wait a minute. Okay, it's created, and before we can connect with SSH, we must associate a public IP to the instance. So we just select associate floating IP to connect to associate a public IP. Select the first, and then keep this as default and associate. Okay, we can now there is a public address of this instance. Let's connect it with SSH. Before we connect use SSH, we need to know the username of the system of the instance, and because we just select the Ubuntu system, so it has a default user named Ubuntu, so we can use Ubuntu to connect. Let's copy this IP and use my SSH tools and to add yes. Wait a minute. Okay, we have logged in, and let's first we should install Node.js, and before Node.js, and we'll install Node.js use NVM. NVM is a node version manager. Node manager and manage tools tool. It can let us install different versions in one system. So let's install NVM first, and we'll open NVM's official site. And we'll find the install method. Okay, we'll just use this script to install. Okay, let's make a NVM effect. Oh, sorry, bash. Okay, let's install Node.js, and we'll install the LTS. Wait a minute, it's downloading. Oh, sorry, it's downloaded success, and now we'll check the node version. Okay, it's Node.js. The Node.js had been installed, and then let's install our apt node CLI. Just wait a minute. it will download some dependencies, and it may take minutes. And we can pay attention to this. We just install the version bigger the version above 12, because our ABT node is running is running at the version of Node.js above 12. Wait a minute, it's installing. Oh, too many dependencies. Too many dependencies in Node.js. It's closing. Okay, it's building. Oh, we saw an error. We saw the error is there is no command make. Okay, let's install the make command. Oh, sorry, abt. Oh, there is another process use sudo. So let's reboot the instance. Wait a minute. And the reboot will may take a minute. Let's wait it. And at this time, let's see more details of the instance. And we can see the details of the instance. And this is a public IP, internal IP, and the security group. We can see the port range. This port, the 2029 port is our ABT node default port, and my the key name is my SSH public key. Wait a minute. And this is the logs. The logs is a log of in the when create the instance. Wait a minute. We can if the let's check if the reboot is done. Oh no. Just a minute. And this sorry, this has a there is a console tab. We can use this tab to connect the instance, but I prefer use terminal active log. And this is something like event sorry, action log. It records some important actions. Wait a minute. This images tab is some images we can select, and let's check if the reboot is done. If the reboot is done. Oh, sorry, no. Just wait a minute again. And we can see a lot of actions here, and we can edit instance, attach volume, and detach volume, and update metadata, and so on. And if you guys has interested in or you can do it yourself. Okay, let's check again. Maybe it's reboot done. It's maybe a slow. Let's again. Oh no. Wait a minute. Okay, it's rebooted successfully. And let's install our ABT node CLI again. ABT node CLI. Wait a minute. It will download some dependencies again. And we'll keep it installed. And let's continue to check out what there is something else in the arrow. And this is volume. Volume is the data disk of the instance. This is volumes I created before, and this is snapshots, and we can make snapshots if we need it for the instance, and so we can use the snapshot to build an image quickly. To build an instance quickly. And let's back to computer instance. Let's check the installation. Okay, we can see we have just installed. Oh, I'm sorry, I forgot to install make. Wait a minute. It's close to. Okay, let's install again. It's fetching data. We can see the progress is more quick than before because npm has cached some dependencies. Okay, we have installed apt node. Let's check it. Okay, let's init a configuration files like we have did it in our first demonstration, just like in my Mac. Init. I know I will set. I will use the value to. We'll use the default value and IP. I'm sorry. I set it the wrong IP. I should set the public IP. So if we set the internal IP and we can't access the apt node from public network, so we have set it with the public IP. Default and public IP and the port block registry and the configuration file, and then let's start our node. Okay, we can see our node is started successfully. Let's visit this IP and port in the browser and paste it. Wait a minute, because the first visit is always slow, because there is nothing, there is no cache in the page. Okay, now we saw this. We see this QR code the first time, and now I will set. I will use my apt wallet again. Wait a minute. It's a little slow, so just make a wait a minute. Okay. Okay, I have authorized, and the information I will keep it at default and complete the setup. Okay, let's take a tour. And we can see this dashboard has been can be accessed now, and we can see the IP is the instance we just created in of this. So this is the whole progress of how to install our apt node on the Oracle Cloud, and we take some time to configure our server instance, and take some time to install dependencies. But the whole progress is mostly and is simple. And so this is my demonstrator of deploy on Oracle. And then let's oh, I'm sorry. No. This is the steps of install on your launch instance and setup instance and install apt node CLI and so on. And next, let's see. At last, we'll demonstrate how to deploy our apt node with node launcher. And apt node launcher is a blocklet, in fact, and it contains some cloud service. We can create our apt node. Just now we only integrated AWS in it, and later we will integrate some other cloud service like Microsoft Azure or and Youpayun and Oro and so on. And let's see how to deploy it with apt node launcher. And I just said it's a blocklet, so we can use it in a running node. And I will use the running node. I just deployed it on my Mac OS. So let's check what's the address of my node of my apt node. I will exit the server. Okay, this is my Mac OS system. I'll start. This configuration, this node I just initialized in step 1. I will use it directly. Okay, this is my local IP, and copy it to my in my browser, and this. Okay, let's install the blocklet, and it's here. apt node launcher, install. Okay, we can see the installed launcher is in blocklets list, and we started. Oops, we can't start it because to deploy apt node we need the access key and access ID of the target of cloud. So let's set it first. We can see configuration is a requirement. So let's set AWS access key and access ID because just now just like I said, we now the apt node launcher will just will not only support the AWS. So now I will configure. Now I just configure it with AWS access case, and because this is a secret of my my AWS account, so I will hide this process setting process. Just a minute. And I will set it. Okay, I just set it. I just set the AWS ID and AWS access secret. Now I can start apt node launcher. Okay, after I click the start button, we can see the admin interface of the node launcher. I just visit it. Okay, we can see the admin page contains instance list. Now we will create a new instance with click launch node, and this is a cloud list here, but now we just integrated AWS, so we just select AWS and then next, and then select the place. I will select Asia with Mumbai is in India, or next. Wait a minute, because it has to take some. Okay, it will take some time to launch the information of the instance, and I will name the instance with apt node launcher AUNCHER demo, and apt node version. And this is the latest image version on the AWS, and this is instance type. I will set a default. I will keep it the default, and I click launch. Wait a minute, because the apt node launcher will request APIs to the AWS to create instance, and now we have launched successfully. So let's view the node details. Okay, we can see this is the instance we just created, and we can see the type is T3 we just selected, and now we can visit now the node is created on the AWS, and we can visit the node with the address. Let's visit. It may take some time to take effective. Okay, is now can access. Wait a minute. Okay, we see this QR code again. Let's authorize it again. Use my apt wallet. Okay, this is we can see the EC2 user and the description, and we'll keep it at default. Complete setup. Okay, let's take a tour of dashboard. Okay, this is apt node and is running now, and is created by the apt node launcher, and the node launcher created on AWS. So this is how apt node launcher to create a node with a cloud service, and later we will integrate more cloud services like Azure and Yun and Oro and so on, and we'll make our node deploy more easier. And this is my whole demonstrate about how to demonstrate about how to deploy our apt node to kind of different environments, and I hope you guys can I hope you guys like it. Thank you. Bye bye.
All right. Thanks again, everybody. And this is a good chance to go ahead and grab a cup of coffee, or if you haven't had a chance to go to the website, devcon.arcblock.io, log in with your ABT wallet. Go ahead and select the tab at the top to get your badges. So each session we're hosting, you can get a unique non-fungible token badge. I encourage everybody to go ahead and collect them all. So ABT Node, what we just saw in that session, obviously it's very cloud friendly. It's cloud native design. And that's really the goal, is to make it flexible for everybody. So as we move ahead, what we want to consider, so ABT Node really represents the foundation of the ArcBlock platform and blockchain framework. As you can see there, it was pretty easy to set up on your local device, supports cloud instances, containers, servers, embedded devices, and more. Actually, I would encourage you, we recently just did a Raspberry Pi demo. If you haven't actually checked that out, just go online and do a search for it and you can find it. In the end, what we want is ABT Node, we want it to work for you, and we want to support applications and support projects the way that developers want to build them. So what we're going to do during this next session, now that we know how to actually run the ABT Node, let's actually go a little bit deeper into the ABT Node, which he had actually mentioned there during the close of the session. Two of our engineers this time are actually going to do a deep dive into the ABT Node. So we're going to get ready for some code. And as a reminder, if anybody actually missed anything here along the way, these sessions and slides will all be available after the DEF CON. So let's go ahead and get ourselves started and give them just a minute here to get ready. All right, let's go.
Hello everyone, welcome to our ABT Node and Blocklets workshop. This is a workshop that will get your hand dirty. Please bring your laptop and get it connected to the network to join this workshop. And this workshop is brought to you by me, Shijun, and my co-worker, Zhenqiang. The agenda of this workshop is as the following. First, I will guide you through the process of environment setup, in which we will install NVM and use NVM to install Node.js, then the VS Code editor. After that, we will install and initialize ABT Node on our local machine. Then we will start the ABT Node and set up ABT Node with our ABT wallet. And then we will I will walk you through a few of our existing blocklets to show the features of ABT Node and blocklets. Now, and then my coworker Zhenqiang will demo how to create new blocklets. And finally, we have a simple frequently asked questions list for you. Okay, then let's start. First, for environment setup, we need to install NVM. NVM is a node version manager. It's designed to install per user and per shell. It works on most systems, either it's Unix or Mac and Windows. Install NVM is quite easy. You can copy this line here and paste it in the terminal. Oops, the wget seems broken. Let's try another way. Let's use cur instead. And it's prompting me that the NVM is already installed here, and it's trying to upgrade it. And the upgrade is complete. Then, when the upgrade is complete, when you type the NVM and hit enter, you will see the all available commands and options for NVM. Usually, after install the NVM, you need to spin up a new terminal tab. And then we can use NVM as remote grep 10. We will install Node.js 10 plus with NVM. Okay. Then let's install. If you have not installed Node with 10.21, then NVM will download the binary and install that for you. I'm already installed it here. And then let's move on to the next step. The other tool we will be used is VS Code, Visual Studio Code. Visual Studio Code is an awesome code editor for engineers to write code. And beyond that, and the fourth setup, the final setup for this workshop is the ABT wallet. If you have participated our previous sessions and workshops, you may have already get ABT wallet up and running on your phone. If you have not, please go to abtwallet.io, and here are the download links for the ABT wallet. It's supported on both iOS and Android devices. You can download our ABT wallet from App Store and Google Play Store. Then let's move on. Since our environment is set up, let's move on to the next step. We will install apt node and initialize the node config. Let's install apt node with install the install process may take minutes to complete. It depends on your network connectivity. If for English users, please use the official npm registry. Another way to install apt node is use the yarn package manager. The command may need to be changed to yarn global add at apt node CLI. Let's wait for the install to complete. And while we are waiting, we can do a little cleanup from our environment in order to get a very clean environment. That said, we need to remove the default apt node data store and config file from our home directory. We are almost there. Okay. We have apt node installed. Let's check its version. The latest version of apt node is 0.30. And then let's init to make sure we are running the same version of apt node from our environment. We can use which apt node to get the current used binary, or you can, just in case if you have multiple instances of apt node binary, you can use which-a apt node to list them. And I am using the binary just installed, and we are okay to continue. App node, let's initialize app node config by running app node init. Press enter, and I will be asked few questions. First is the name of the node. Let's accept the default. Then is the description of the node. Let's name it as the demo apt node. Then it's the directory where we will store the data of the apt node. Let's accept the default. Then it's a choice of which IP our node will be served on. Let's use our internet IP. And then the port, use the default. Then is the blockade registry. The app node will fetch the blockade list from. For English users, we can just use the default. Okay, then the config file path. Let's accept the default. Then we can see that our app node configuration file is generated successfully. Let's catch the file and see what's inside. It's a typical YAML file. The name, description of the node, and what's not mentioned in our above UI is the key pair, which is ASCII, PK, and DID of the node. And this is a random generated key pair for the node. And these are from the interactive CLI interface. Okay. Now I think we are ready to move on to start the node. But first we need to get our empty wallet ready. Let's move it here. Let's unlock the device. Then let's start the node with apt node start. Now we can open this link in the browser. And this is the interface of setting up the node. Setting up the node means first we need to connect the node owner apt wallet, which is this wallet from on the right. And then we can do some changes to the basic settings of the node. Then we are complete and ready to use the node. Let's scan the QR code with our apt wallet. To make things work, please remember to connect your phone within the same network of your node. Here we can make changes to the name and description of the node. Let's just keep it unchanged and complete setup. Okay, then our node is successfully set up. And we are redirected to the dashboard of the node. Then let's walk through some of the basic features of apt node. From the dashboard here, we have few sections. The first is the overview section. You can see how many blockades are installed on this node and how many users. And the node, it can be managed by multiple users, and when the node is created and when the node is the uptime of the node. The second section is the storage section. This section displays the details of how much disk space are used. how much disk space is used by the node, the blocklet space, the blocklet storage, the log storage, and the core storage. Currently, we don't have any blocklets installed, so the blocklet storage is zero, and our core storage is about 7 kilobytes. And the third section is the DID section. This is critical because from here we can know the DID of the node and the owner DID of the node, which is the DID of the logged in user here. And the last section is the environment section. From here we can tell the version of the node and the internal and external IP of the node and the operating system and whether it's a Docker or image. This is the dashboard of the node, and on the top right corner, there is a language switching drop-down for you. For your convenience, and this is the notification. We can see that the currently notifications shows some important activities happened in this node. And for the settings tab, we can tell we can change the basic settings of the node, but please be cautious when you change these two settings, as they may break the node. And for the team part, you can when another user rather than the owner try to log in the node, is blocked. But once you approve the user here, then that user is marked as member, and he can log in and has full control of the node, just like the owner. And for the blocklet tab, here are the list of the installed blocklets, and it's the central place to manage installed blocklets, such as config, start, stop, and restart or uninstall them. And this is the marketplace page. This page listed all our current published official blocklets here. You can install blocklets here, or upgrade or downgrade a blocklet from one version to another version. And here is a developer tool, which is the GraphQL console. From here you can compose a GraphQL query by just clicking on these fields, and then you click this button, you will get the result. And all GraphQL endpoint queries and mutations are supported in this GraphQL console. You can feel free to try. And then let's demo how to install a blocklet. Let's first install this demo blocklet. It's a static demo. Okay, after it's successfully installed, we can open the static demo, or we can go from here and click here. This is the blocklet detail. We can start the demo. Then if the blocklet has a public interface defined, we can visit the public interface. And this static demo just serves a static game, which is called 2048. The game, users can combine numbers to get higher scores, and the game will end if there are no more squares to combine. Then I think there are I think we are done with the static demo blocklet. It's pretty simple because it only serves static files. Then let's play with the df demo blocklet. It's named kitchen sink blocklet. Here, let's first install the latest version. And this blocklet has many includes many features of our blocklet specification, such as hooks and different interfaces. Let's try to start the blocklet to see if we can start it. Okay, now it's started. And this is the public interface. The public interface is pretty simple. It just print a sentence to say hello. And the admin interface is enabled in ABT node. The admin interface is also protected by ABT node. If a user tries to visit the admin interface from outside the ABT node, you can see that it's forbidden. And for the config interface, we can see it's very similar to the admin interface. And from the blocklet detail page, we can see other important info about the blocklet. First is the disk info. We can tell where the blocklet is installed and how much disk space it takes. And for the runtime info, it's only available when the blocklet is running. We can tell how much memory it's using and the uptime of the blocklet, which port and which process it's using. And for the configuration part, we can tell there are 3 different sections of the configuration. The last one is the global or system configuration. It's all the same for all the blocklets on the same node. And for the blocklet configuration section, it's different for each blocklet. And for the user configuration, it's defined in blocklet meta, and it may be required or not. And the user can edit them here or delete them. The blocklet and the system configuration cannot be changed. And then let's try to see if we can get the hooks work. The blocklet is forbidden to start when the minutes of the current time is even. And we can wait a few seconds where we are installing blocklet for later demo. Next we will install the blockchain manager. Let's just install it and get back here. See if we can start the blocklet. Now we can see that the blocklet start failed because it can only be started in even minutes. And that's controlled by the hooks defined in the kitchen sink blocklet. Okay, next we will walk through the most important blocklet in ABT node, which is the blockchain manager. The blockchain manager blocklet can be used with a few other blocklets that let users onboard and experience our blockchain-related technologies and products. First, we can see that we have a blockchain manager blocklet installed. Let's start the blocklet. and then visit the main interface, and then let's create a chain. Let's just keep things simple. Here we need to generate a moderator key pair for the chain, which is the administrator of the chain. Let's scan the QR code with ABT Wallet and select to confirm. Then we can say the moderator DID is populated here. And here is an important note for the chain creation. If you install the blockchain manager for the first time and you are creating the first chain, our first release for this version here may not be downloaded yet. So the first chain creation operation may take some time. And while we are waiting for the chain being created, let's walk through the further release management feature. Here we can see a list of all our public forge releases, and we can see that the latest version is downloaded. There are 4 components there. It's also locked because our new chain is using this release. Now let's head back to our chain list. It says it's created, but it's stopped. And then let's start the chain. The chain start operation may take 10 seconds or more to complete. Now since the chain has started, it's running. And its block, we can see that its block head is incrementing when time goes, but the transactions is still 0. We need to have some way to get some data into the chain, and we need some way to read some data from the chain. Then we need to install a few other blockades. The first is the Blockchain Explorer, and then GraphQL Playground, and then Blockchain Boarding Gate. Let's demo them one by one. Okay. Let's start Blockchain Explorer, then the GraphQL Playground, then the Blockchain Boarding Gate. Let's duplicate this tab so we can get more space. Let's go to the Blockchain Manager and list our chains and open the detail of the chains. Here we can view important metrics about the chain. The most important one is the GraphQL endpoint. And then let's open the public interface of the Blockchain Explorer. From here, let's remove data from previous test. Okay. Let's change the IP here to our internet IP. Then click Add, and then we will be able to browse the chain with this blocklet. Let's switch to this chain. We can see that there are no transactions yet. Then let's open the public interface of the blockchain boarding gate, from which we can create an account of our specified chain and get some test tokens from that chain. Let's input the graphical endpoint of the chain. And then choose. Then let's scan the QR code with our ABT wallet. Then we have our account created on that chain. From here, we can see that we have a declare account transaction. Then let's get some test token. Let's refresh this page. Here we have a check-in transaction. Click here. We can see that this is the on-chain state of my account. It's here. The actual account is here. Then I can, maybe you are wondering why we have two accounts here. It's because the token of the chain are stored in the moderator account by default, and this moderator key pair is created during the creation of the chain. So all the tokens are here. We can try to transfer some token to our newly created account. Let's set to confirm. The total account should not be changed since we are transferring among our self accounts. And let's check the block explorer here. The transfer transaction is here, and the account balance is updated. Okay, I think that's all for blocklet walkthrough in our ABT node. There are more blocklets here for you to play with. In our another workshop, we will demonstrate how to play with the wallet playground. This is an awesome blocklet that can demo tons of features of our blockchain technologies and ABT wallet.
Hello everyone, I'm Zhang Zhenqiang. Just now Shijun has introduced something about ABT node and blocklets. And now I will create two simple blocklets to demonstrate how to create a blocklet, and then we'll deploy the two blocklets to a running ABT node. And the two blocklets are a static blocklet and a DApp blocklet. The DApp blocklet is a static blocklet but with a backend. And the first thing we need a running ABT node. I have started a node on my local, and we can see there is no blocklets installed on the node. And later we will deploy the to be created blocklets to this. Let's create our first blocklet, the static blocklet. A static blocklet is a blocklet that only contains a static web app and a configuration file to indicate the web app is a blocklet. And there are many ways to create a static web. For example, you can just create a HTML file, but I will create a static web app with create React app. And let's check out how to use create React app to create a static web. And let's check out the docs. And we can find a command at this. And we'll use npx to create the app. And let's create a directory to deploy to create our project. We called it ArcBlock Devcon. And pasted the command. And we called this project name static blocklet, and enter. Because there are some dependencies to be installed, so to be downloaded and installed. So we'll wait a minute. Just a minute. And if you guys has a Mac or Linux, you can create the app with me. We can see there are lots of dependencies. It's downloading a template dependencies. Just a minute. It's building. Okay, we have created a project. Let's enter the directory and use yarn to start the created web app. It needs building the files at first running, so we just wait a minute. Okay, it's a page we just created, and let's edit the app.js in the src directory to show some character, a word that modify the text. And let me open the project with my VS Code. Just a minute. And the text is in src app.js, and we will change this to ArcBlock Devcon. 2020. And let's see the page. We can see the text had been changed, and we have created a static web successfully. And now let's turn this web app to a blocklet. To achieve this, we need to add some configuration, and this configuration can be described in a blocklet JSON file, like this. The blocklet JSON must be put in the root of the project, and the blocklet JSON are like something group, and the group to indicate or we call it a type. The type of the blocklet, we call it a static, and the type now can be a static or diap. And now we first create a static group, and we have to define the main field. The main is entry of the static app. We will set it later, and we also need a public. URL. The URL is entry file of the web app, and we also set it later. So just something like this. But except create a blocklet JSON, we can also put the configuration in the package JSON, in the blocklet field. Sorry, we remove the bracket. And let's delete the blocklet JSON. And except those three fields, we also need the other description field. And for save our time, I will copy the fields from the doc. Let me paste it and remove the duplicated public, and we can see the other fields like community. Community means the community we can communicate something about the blocklet, and the provider. A provider means the source of the or the author of the blocklet. Just now I set it ArcBlock, and the color is a color scheme of the blocklet, and the color decided the UI on in the ABT node. We just use the default configuration, and then and there is an important thing we need to do is the ABT node just can only serve pure JavaScript or HTML file, but we just created the project. It's a React project, so we need to build the React app to a static file. We can build the we can build the React app with the script in the package JSON. Built. Run is built. In just a minute, and it will take seconds. Okay. Oh, I'm sorry. I forgot to show my terminal. We can see I just now run a command with npm run build, and the command has built the React app to static files, and we can see there is a build folder in the project. These files are the built-in files, and apt node can serve those files, and there is after build these files, those files we need to do another thing to let apt node know how to find the built-in files. And we will use main to indicate where to find the build files, just the build folder, and a public URL. A public URL is the path of the static web app. We indicated slash, and admin URL, because there is no admin page, so we don't need to set this, just remove it. And also we should define the description attribute to the project, because apt node need the description to let the user know what does the blocklet and what it can do. This I said the description to this is a static blocklet, and we can see we have configured the web app, and then let's deploy the web app to our apt node. To deploy the apt node, to deploy to the node, we can use apt node deploy command. Deploy command can deploy the build files to apt node, and we can see the node has no blocklets now, and then let's deploy it. Okay, it shows we have deployed success, and now we can see the page the blocklet has deployed to this. This is our kind of name is the static blocklet. It's created just now, and we can start it. Okay, started successfully, and then the public interface is a page of the blocklet first page. Let's visit it. Okay, we can see it's running on running at port 8092, and it's a ArcBlock Devcon. It's a static web we just created, and it's the same with this, but it's running. But this is running with yarn start, and so this is this is the way how to create a static blocklet, and it's just two steps. First, we need to create a static web app, and then add some configurations to the project, and then deploy it to the node. It's all. And then let's see how to blocklet with a backend. We also call the blocklet with backend DApp blocklet, but the blocklet we will create is not a real DApp. We just to show how to create a blocklet with a server side, and we will create the blocklet based on the static blocklet. And let's stop the service. And to add a backend, I will use Express.js. Express.js is a web framework. It's widely used in Node.js. And let's install. Let's add the dependency. And I will open the terminal in the VS Code. I use yarn to add Express. Just a minute. It will take 1 minute. Oh, it's done. We have installed the Express dependency, and now let's add some server-side code. I'll close the terminal for a while, and I will create a folder named server to place our server-side code, and create an index.js file, and press and to initialize and I will use Express to define an API. The API is used to get the memory information of the server. So use apt-get. If you guys are not familiar with Express.js, it's no matter, because it's not critical to our blocklet. It's just I just show you the blocklet contains a backend. For save our time, I will copy some code from I created a project previous. Just a minute. And I will paste the code I wrote before. Remove the duplicated. And we can see the API memory. The API memory has response the information of free memory and the total memory. and one thing we need to know is that the static booklet which we just created is served by ABT node, but now if the booklet with a backend, the backend need to serve the static files itself. So those six line codes is to serve the static files. We can use express static function, and it will return middleware. The middleware is a concept of Express.js, and this is a root of the first page of the site. And at last, we also need to listen a port to complete the server-side code. The port we set it we just 3030 or and a callback function, and just a simple error handler. If there is an error, I will throw it. Because it is a development environment, so I just handle it simply. And we print a message that the server is started at 3030. It's done, and let's run the server-side code. We will use node.js server-side index.js. Okay, it shows the server has started. Let's see if the API is correctly. We use curl to fetch the API. Local API, local IP, and the server side port is 3030, and API memory. We copy it and paste. Okay, the API is running now, and is running correctly. And then we will add some code in the front end to request the API and show the memory information to the page. Let's see how to add it as the code. And the front code we just saw in the src app.js file. And to distinct the static booklet, we will change the words to the app booklet with backend, and we will use fetch. We'll put in the use effect and use state, and declare a variable named memory and set memory. If you guys are not familiar with React.js, is the matter, and just know it's some code to fetch API from a server. We define it as an empty object, and then we will place the API code, fetch API code to use effect and dependency. Use fetch. Fetch is a new tool to fetch to load the API, and the API is API memory, and get the response, and the response then JSON, and then get the data to set memory formatted code, and a simple error handler just to print in the error with console. And we will display the memory information with a list, and put it in the div memory information. And with URL and li. One is free memory with memory variable. It's we define it in the API free memory. Copy it, paste it, and copy the line and change the text total. And the total. And we just complete the front end code, but now we can't access the API from front code because front code is running on 3000 port, but the server is running at 3030. So we have to add a proxy in the package JSON to proxy the API, and this is showed in the Create React app tool. We can find it in the docs of the Create React app. React app, you can see at this integration, backend integration, proxying request. I will just show the doc. Let's continue. And the proxy, its value. Oh, sorry. And its value is local host. And the server port is 3030. Okay. And now let's start the front end server to check the page is okay. And use start. It will take seconds to build the files. Okay, we can see the information, the server memory information has showed in the page, and we can also change the title of the page. Oh, sorry, I forgot to show the page. We can see the information we have, the text we have. We just changed the memory information free. And let's add a unit of the free memory, and it's bytes. App.js, and add bytes. Okay, let's show. Okay, we added and change the title. The title is now is React app. We change it to ArcBlock. No, the app blocklet, and the code is placed in public index.html. We can see it here. Change it to ArcBlock the app blocklet ArcBlock Devcon. Maybe it's a little long. Okay, let's show the page. We can see the title has been changed, and then let's find let's put this dep blocklet to our apt node. In the static blocklet, we built the front. We built the front end code from React.js code to pure JavaScript and HTML code, and also we need to compress the server-side code to one file named blocklet.js because apt node required the compressed code one file. So we need a tool to do this, and the tool is also provided by the apt node's command line. So let's see how to build it. Okay, apt node. We can see how many. We can see there is a command named bundle. We can use this command to compress the server-side code. Just run apt node bundle. We can see there is something error occurred. Let's see why. Let's solve it. Wait a minute. Okay, we forgot one thing. To bundle the blocklet, to compress the server-side code, we need to let node know where is the server-side code. So we need to modify the configuration defined in the blocklet. It's here. First, to change the group to the app, from static to the app, and the main. If the blocklet is a static blocklet, it's a entry folder of the code, and if the blocklet is the app blocklet, we should change the value to the server-side entry file, and our project is server / index.js, and the other and it's okay, and let's continue to bundle. Clear the terminal. Okay, we can see apt bundle has successfully has successfully executed, and after compress the server-side code, we need also to rebuild the front-end code because if we don't rebuild it, the previous static blocklet is the same with our the server-side code. So before to rebuild the front end side, we better to change the description and name of the blocklet to distinct with from a static blocklet. We name this with we change the name to the app blocklet, and the version to 1.1.1. And this is the app blocklet. And now let's rebuild. Keep in mind, npm run build is build front end code, and bundle is bundle server side code. Wait a minute. Okay. Let's see where is the build file placed. And we can see there is a blocklet folder, but it just contains package.json and a README file. There is no built server-side code because we have missing a config named files to indicate where which files we should to deploy. So we can define it with files field, and it's blocklet then.js. The reason why it's blocklet then.js is a protocol with the blocklet because the server-side code all compressed by the ABT node to the blocklet.js, and put the build files and README. We also put the README. Oh, sorry, read READ me the .md and package.json, and that's all. We just put those files and let's rebuild. Okay, we built it successfully, and let's check it again. There is no. Oh, sorry. We shouldn't run npm run build. We should use abt. The copy abt node bundle will copy the build files to the blocklet folder. I'm sorry. Okay, bundled successfully, and check again. Okay, we can see the build file, compressed server-side code in the blocklet.js and front-end code. And now we can deploy the build files to the abt node, and deploy we can use abt node deploy also, and the command can find the blocklet folder to the node, to the abt node, because it is also a protocol between abt node and the blocklet folder. Okay, we deployed it successfully, and let's check it. Let's check it in the ABT node. Let's to the blocklet list. Okay, we can see the version, the app blocklet with the version 1.1.1.1, and then we can start it. Okay, the public interface. Oops, something error. It's error because we forgot to change the port. We have just set the port. We have just set a port in the server-side code, but the port, the blocklet port in the APT node is assigned by the APT node. We shouldn't set it a static value. We should set the port with a environment variable. Let's change it. Okay, let's change it. We can get it from a process. Not. Okay, we have set the port. Wait a minute, I check it. Okay. Okay, let's bound it again. Okay, and also we check. We also check the configuration is correct because there's something error. So wait a minute. Okay. Let's after bound we can deploy. And the deploy command will reload the ABT node daemon. So we need not we no need to reload it manually. And let's check the node and go to the blocklet list and restart blocklet. Okay, we can see the status is running, and let's visit the public interface. Okay, the blocklet is deployed successfully, and this is server side. We can see the app blocklet title and the memory information of the of my computer, and this is the whole process how to create a blocklet to with a backend. And if a blocklet with a backend we have to compress the backend code and put them in one file. We can do this with ABT node deploy. ABT node bundle, and after bundle the backend code and bundle the and build the front end code if needed. After this, we can deploy it to the blocklet, and this is the two blocklets we have created and deployed it to the ABT node successfully. And there is another thing. How can we debug it if there is something if there is error occurred during the development or in the production? We can set a debug variable, processing variable with ABT node prefix, and this with this set with these settings we can see more logs of the ABT node, and how to view the logs of the blocklet. And we can see we can find the logs in the disk info tab of the blocklet detail page, and we can see there is a log directory, and we can see there is no log is printed in the directory. But if there is something, if there are some error occurred, we can check the directory listed here. That's all I shared. Thank you, everyone. Bye bye.
All right, that was a great session. Great to see real code happening in real time, mistakes and all. So that was a great look at our ABT node and blocklets and some of the things that you can actually do with that. I just want to give a quick shout out to our developer community. Right now there's about more than 1,700 viewers right now on the stream, so we appreciate it. And for everyone, if this is your first intro into blocklets, so blocklets are really designed to be many things. It's a framework, really a container framework for that can be used for standalone apps, reusable components, even smart contracts to extend the features of your blockchains. And I think it's really important to note that for ArcBlock developers, one of the goals is to give you flexibility and choices with your ABT node. Really, ArcBlock, our blockchain framework, and the ABT node, it isn't a one-size-fits-all platform, but rather a really flexible container that gives you the ability to add new features, using the single-click blocklets. For example, in this last session we just watched here, you could see you could build blocklets with different backends. So with your ABT node projects, you don't necessarily need to leverage a blockchain, but instead can actually leverage or use different backend technologies for your project, including a relatively new service from AWS that is able to deliver blockchain-like features, but it's actually a database. And in this next session, I'm really excited to share with you, we have AWS and ArcBlock who are going to show you Amazon's Quantum Ledger database and many of the amazing features that are actually built into what's called QLDB and that can be brought to any project on the ArcBlock platform and ABT node. And we're also going to show you a little bit how to start using it right away with the ABT node. So I'm going to hand this over to Lana Kalashnik and Jonathan, ArcBlock engineer, for a jump in, and let's take a look here.
Hey everyone, my name is Lana Kalashnik. I am a principal blockchain solutions architect at Amazon Web Services. Welcome to this ArcBlock Devcon 2020 session on Amazon Quantum Ledger database. We wanted to show you a little bit more and tell a little bit more about QLDB, which is a new backend integration that's available via ABT node on ArcBlock Dev platforms. So in this session, we will dive deeper into some of the basics behind what makes ledger databases different, how they're different from blockchain implementations, and go over a couple of use cases of how these technologies are being used. All right, so when we're looking at ledgers and audits, ledgers are not a new concept. For at least the last 5,000 years, record keeping has been a central theme for all civilizations around the world, and they have to deal with the same kinds of problems the way we do today. So traditional ledgers have been a book or other collection of financial accounts of a particular type. However, today we see ledger applications used not only in financial cases, but in any situation that requires any type of a system of a record. So some may ask, why does immutability and verifiability matter for a database? We have heard from many customers in various industries that this helps them to reduce risks. So that helps you ensure safeguarding of critical system of record application where data loss could be expensive. It also improves data tracking. So it helps you or any parties that have access to the system to quickly and accurately track data, entire lineage of the data, improve efficiency in tracking the source of issues. So for example, manufacturing defects, maintain supply network, data hygiene. It also provides for easier audit. So this way you can reuse downtime caused due to audit and compliance issues, having hundreds of productivity hours for your team, and also reduces implementation effort. So building in immutability and verifiability in a traditional way is time consuming, it's cumbersome, and turns out to be pretty expensive down the road. So there are some challenges with the current approaches to building ledgers with audit capacities. You may ask, what are some of the problems that our customers have been facing while implementing ledger or building system of record applications using traditional databases? Well, typically customers do this with relational database using custom audit trails and audit tables and so on. But at the end, it's pretty hard, it's complicated and expensive to build out and maintain systems. Also, relational databases are not inherently immutable. So this transaction history can be updated or overwritten. So there is no way to verify that something or someone who has full access to the system has not accidentally altered this data. Because of this and talking to thousands of our customers, we came up with the concept of ledgers with decentralized trust. So here we're talking about systems of here we're talking about systems of record for financial institutions with peer-to-peer payments, mortgage and lenders. So here we have some more of a more complex process around syndicated loans. In retail, streamlining customer rewards and also inventory management and supply chains, typically international supply chains. So in this use case, blockchain networks with decentralized trust are a preferred where to go. But we also found a different class of use cases where it was actually better to implement a ledger for transactions with centralized trust. So when we're talking about centralized use cases, the ledger serves as the transparent, immutable, and verifiable record for a company's application and does not have the notion of a full-blown decentralized trust. And I will explain what that means later. Essentially, this means that this is the ledger itself, that it can be managed by one central authority. There are some mechanisms for which you can tie, let's say, digest or verification of nothing having been altered to wider blockchain networks, but we will dive into that a little bit later. So some of the use cases here are in healthcare, in DMV, for example, tracking a vehicle title history, in manufacturing, and a lot of other use cases. Because of this, we've launched Amazon QLDB. So Amazon QLDB is a fully managed ledger database that maintains a complete and verifiable history of ledgers over time. So in this diagram, we can see the what it looks like under the hood. So from the application perspective, a customer or a user would interact with QLDB just like they would with any other database, but it consists under the hood of two major components. The first one being the journal. So the journal is an append-only immutable journal that stores sequenced cryptographically verifiable entries for each change made. And this includes the entry itself, so the transaction, metadata, and the call being made in particle. And I will explain what particle is later on in the session. And the second large component is the current and historic histories. So here we can see the current state of the ledger, and we can pull up the indexed history for all of the changes for a transaction. This is the first of its kind solution because of the fact that QLDB is a journal first. So typically when we're talking about concept of logs or journals, this is not a new concept. Typically we address a ledger or we look at a journal or a log in a database senses when things are not going that great. So either we need to pull up and understand why some transaction failed, or if we're looking to replicate log or replicate transactions within the database. The problems with current ways of leveraging logs is that they weren't designed to be directly accessed. So it's usually an afterthought figuring out how to access these logs. And also they're not readily cryptographically verifiable and immutable. So we've baked in those two concepts into the journal itself. So whether you insert data, you update or delete data, all of these transactions are added as blocks to the journal. And here we're seeing that we're seeing 3 blocks in the journal that are added here. So this is inserting data. So for example, we're adding a new record of ownership for a vehicle. So we're adding, let's say Tracy owns a Tesla A, then updating data. So this could be another block added here, changing ownership of the vehicle from Tracy to Bob. Here what we're seeing is that both blocks are cryptographically linked to each other via hash chaining. And we're also able to add a delete call or a delete block. And this is a pretty powerful concept when we're talking about comparisons to blockchains, is that in the current and histories view, we can reflect that the item has been taken out of the our inventory, for example, but we do have this block that has information on this Tracy's vehicle that has been deleted, let's say, from our inventory, from our ledger. All of the transactions are immutable at the journal level. From current state, let's say we can update, remove transactions. So from that perspective, there's a lot of flexibility in having an immutable journal itself, but being able to run any operations on the current state and being able to pull up a full history of changes to your record. So in this example of managing a car that initially was owned by Tracy and then by Bob, is that we can pull up by VIN number, let's say index history of all changes. QLDB also supports a SQL-like query language called Particle. It's extremely flexible, and we will touch on that in a couple of minutes here. And it's also a document database. So it does have ION data format, which is a superset of JSON. It's a strongly typed superset of JSON at that, which allows for numeric evaluation of decimals. And if you've parsed JSON before, it's kind of hard to do whenever you have to guess what exactly number type you're using, especially when we're talking about nulls. It is also serverless and scalable service that is fully managed on AWS. All right, so what is a journal? So the journal itself is this log of transactions that is sequenced. So each block within the journal contains the transaction data itself in ion format. It contains the hash, so this is your block hash, and other metadata such as timestamps. So all of the document revisions are stored in the journal and are linked to each other. So here we're seeing that each sequence is cryptographically linked to each following entry in the journal. All of the records are immutable. So here we're seeing that the journal is append-only and sequenced. Actually, we didn't even build in any API to be able to remove or change any records from the journal itself, so it cannot be altered. And you can produce a digest at any point in time. And digest, essentially, if you're familiar with the concept of Merkle trees, is the tip of your Merkle tree. So you know that by comparing the hash, your SHA-256 hash, you can verify that nothing in the digest itself in the previous blocks has been altered. And if we wanted to touch very briefly on cryptographic hash and what we mean by this, so here we're talking about hash functions, which provide encryption by using an algorithm and no key. So they're called one-way hash functions because there's no way to reverse the encryption. No matter what the content of your document or transaction is, it is hashed into a fixed length hash value, which is often called a message digest or simply a hash. So by comparing hashes of data calculated at two different points in time, you can determine whether something has been changed meanwhile. So it's a pretty common approach to making sure that any changes to data within a database or any fields can be detectable. So how does cryptographic verification work in this case? So here we do have these blocks, or the concept of the blocks in the sense of QLDB that we've discussed, that contains the particle statement. So this is your SQL-like statement, let's say to insert, update, or delete a record. The record itself, so this is your ION document, which is a superset of JSON like we've discussed, and the metadata, and it contains a record hash. So at the end of, or at any point of time, let's say we've committed thousands of transactions and we want to save a copy of a digest, which is this final SHA-256 hash at this point in time, we can download this digest and save it locally on file and be able to come back, let's say, a year later and verify that none of the transactions have been altered. And that is possible because of one-way cryptographic functions via hashing. So I really wanted to touch briefly on Amazon Ion and Particle. These are really powerful new open source technologies that we've introduced as a part of Amazon QLDB launch. Amazon Ion is the way we store data in QLDB. So this is a document database. So it does allow for SQL-like querying capability, but it's good to keep in mind that actually it's a document DB under the hood for when you're designing your data models. Ion is a superset of JSON, which supports some additional data types. So for example, like I've mentioned earlier, instead of supporting a number, you can specify a decimal, let's say, and also you can specify number types for nulls even, which is really handy if you're looking to determine whether a null is a decimal null or a different number type. And like I've mentioned, it's a strongly typed data format. It is open source, so if you feel like you wanted to use or check out this format on your own, please feel free to download it. Here is the link to the GitHub repository with all the binaries you would need. And also ION documents can be complex and hierarchical, so which is really handy to manipulate large amounts of data. So this really helps us to create a more complex structures for processing. And the second open source technology that we've open sourced recently is Particle. So Particle is a SQL-like query language that natively supports complex structured data. So the coolest thing about Particle is that you can use your SQL queries or SQL-like queries, and you can query both structured and unstructured data with that, which is a really powerful concept. So here we're introducing a dot notation. So when we are looking to pull up an attribute, let's say of a vehicle that is a document stored within a table, we can say, let's say, vehicle.color. So from that perspective, we're cutting out some of the nasty queries that can be associated by building subqueries in traditional SQL. So that's something that our customers are finding as a quite powerful aspect of a Particle. It's also open source, so please feel free to pull it down. So it's used by multiple AWS services. So this is also an internal technology that we're bringing to market, just like QLDB and Ion. And it's worth noting that we've been using QLDB under the hood for many, many years. That's how we scale some of our most performant services. So this is a tried, true technology. So something else I wanted to touch about is that all of the QLDB transactions are fully compliant with ACID. So this is your atomicity, consistency, isolation, and durability. And this is really important for important and regulated data loads. So here we're eliminating potential write skews, phantom reads, on-run repeatable reads. So essentially, these tend to happen whenever not all the transaction didn't fully commit to the ledger. So in this case, we can be fully comfortable knowing that either the entire transaction atomically succeeds or fails, in which case you can retry submitted transactions later on. So a very powerful concept that is not typically available in other ledger technologies. So some of the other QLDB features, because this is an Amazon managed service, it is available within multiple, it automatically is provisioned in multiple copies per AZ, so it depends on which availability zone you're launching it. So you do have this automatic replication between 3 AZs, which is really important for HA and data availability. And it's pretty easy to use. So the team has been putting in a lot of work on building out new SDKs and drivers. So right now we have drivers in Java, Python, and Node, which are available on GitHub. We do have a purpose-built SDKs for QLDB, and it's pretty flexible and schemaless. So again, I would strongly encourage you to dive in and look a little bit deeper at Ion document format, and just really look at some of the flexibility that introduces into the equation. Something else that's very interesting is introduction of streaming QLDB out of the journal. So I think I'm not the only one who had to swap out databases under the hood. So as we were building these blockchain networks, sometimes where we store the ledger, the needs might change. So QLDB has been for me, for example, in my development work as golden copy. So essentially, as I persist transactions, I know that they're stored in a very flexible Ion format. I can have a full historical data of all of the permutations on the transactions that have been committed to the ledger. And from that point on, I can stream out all of these transactions and replay them via Kinesis-powered data streams into, let's say, object stores such as S3, could be time stream database or anything else. And this is a powerful complex because if I decide to use, let's say, a different access pattern to where I choose to, let's say, perform analytics or really focus on time streams or other machine learning, I can easily switch out where I'm streaming out data out of QLDB. So you can emit these transactions and data directly to Amazon Kinesis data streams and go on with your business. So this is why we've built Amazon QLDB. if you have any questions on how that's different from blockchain solutions, please let me know. So the main takeaway here is QLDB takes care of cryptographic verification in a very lightweight, flexible way, which allows blockchain builders to focus on figuring out the right consensus mechanism in smart contracts engine that could be layered on top, which is exactly what ABT provides with using QLDB as the ledger, and then the rest of the platform sits on top of it. So I believe we do have a demo later on in the day, so very excited to check that one out. I will touch really briefly on some of the customer use cases. So we are seeing quite a bit of adoption with ledger databases. So the use case range from track and trace to inventory management to asset provenance. So here we're really looking into how those are used, and digital wallets. So one of the use cases here is our work with BMW, which you can pull up as a case study, activity trackers, data marketplaces. So a lot of tons of data that could be stored in the ledger-like append-only manner, and then later on be manipulated, let's say, to derive any insights that you might need. Like I've mentioned a second ago, one of the use cases that's pretty exciting is a BMW. So here we've built a wallet that essentially is representation of a vehicle's history here, so for automotive data and so on. And another example that's quite easy to get through, if you get a chance and you wanted to get into QLDB console, there's actually a built-in simple data set that allows you to really step through creating a transaction, appending it and deleting it. And the example is for the driver and vehicle licensing agency. So it's an actual use case that we've implemented for a customer in the UK, which is pretty cool. And also for Trust Fabric. So here, when we're going back to where we started in this presentation on looking deeper at ledgers of system of record and understanding how accounting is done. So Sage is redefining this trust fabric between multiple entities. So I strongly encourage you to look into some of the use cases of how some enterprise customers are using ledger and cryptographic verification technology. Thank you so much for your time today. Like I said, my name is Lana Kalashnik. I'm on Twitter. If you wanted to get a hold of us personally, please email this alias, and one of us will make sure to get back with you. And I hope you enjoyed the rest of your session and have a great weekend.
Hi everyone, this is Jonathan from ArcBlock, and in this section I'm going to show you how to use AWS QLDB in ABT Node. As you can see in the previous section, AWS QLDB is a cloud-based ledger database, which would be very useful in many use cases. And so in this case, we at ArcBlock, we decided to make adapter layer that allow our users to plug into QLDB pretty easily when they, especially when you have experience working with ArcBlock's blockchain before. And the basic steps for doing this integration is first, you need to create an AWS account and create a QLDB ledger database. And also you need to set up a IAM account for the QLDB access for the node. And then you just run your node and install a block that called the QLDB manager and use the AWS IAM credentials to basically assign them to the blocklet so that it can access the ledger database on your behalf. And then later on, if you want to, you and your code, if you want to visit the QLDB database, you basically just need to send request, a GraphQL request, the same way you did for ArcBlock blockchain backend. So now I'm going to walk you through using a demo. So now you can see I'm here in the AWS console, and here's the QLDB page. And here in the ledgers tab, I've already have some ledger database set up, and the one we're going to use is the OCAP QLDB demo database. And now let's go back to our newly set up ABT node. And let's go to Marketplace and try to get this QLDB manager installed. All right. So now we have QLDB manager installed, and if we open it, it will like alert us saying the configuration in red should be provided to start blocklet. So we are missing two configurations. One is the access key ID. The other is secret access key. So these could be found in the AWS IAM management console. So I have this already set up, this demo account set up here. And I'll just copy and paste and assign them to the QLDB database, QLDB manager. And then the ledger is OCAP QLDB demo. If you're using a different name, you can modify it, and also the region we're using US West 2. So now we have all the configuration set. Let's go ahead and try to start it. All right, so now you can see here we have a public interface. So this interface is actually a GraphQL backend endpoint. So if you're familiar with working with ArcBlock blockchain, you know that the ArcBlock blockchain also provides a GraphQL interface. So you as a developer can send GraphQL requests to the chain to get the status of accounts and transactions and things like that. And we are trying to provide the same experience for developer when working with QLDB. So this is actually what the QLDB manager does. So it acts as a adapter layer. So you can basically use the same method you used working with ArcBlock blockchain to just switch the GraphQL endpoint and pointing towards the QLDB manager, and then you'll be able to write data into the QLDB database or read data out from it. So let's do a quick demo and see how it works here. And we have another blocklet called blockchain boarding gate. So this is a simple blocklet that allows you to specify a blockchain backend with the GraphQL endpoint, and then you can scan the QR code to create an account on that backend, and also maybe try to get some token from the backend. So let's go ahead and try this boarding gate blocklet. So let's use this this backend as the blockchain we want to connect to. And now we can use our wallet to scan the QR code and create an account. So, and then we can scan the QR code here to try to get some token. And later on, we will be able, or we can go to the ledger database to check if this account and the token transactions are actually recorded in the backend. So, and now let's go back to the GraphQL to the marketplace. So we have a blockchain explorer blocklet. So in the previous section, we introduced this product. So this is actually a universal explorer that you will be able to just specify a backend, and then the explorer will be able to track the accounts and transactions and stuff from that blockchain. So let's go ahead and see this one here. Let's try to add the backend here. And now let's switch to this blockchain backend. And as you can see, we just declared an account, and we also just did a checking. So if we look at this account, we can see that this address has 1,000 demo token. This is because we just scanned the second QR code to did a checking. And so this is how it works here. And let's copy this address and go to this query editor and see if we can check if the account is actually created in QLDB. And as you can see here, it's actually created. All right, so what we did is just a simple demo to showcase how to integrate with AWS QLDB in ABT Node. And I think this is very powerful for people who want to use a cloud-based ledger database to tackle some enterprise use cases. And you guys can try it out with the latest ABT Node and the blocklet. And feel free to reach out if you have any questions or problems hitting when you're trying to set up this integration.
All right. So that was great to see. So QLDB in combination with ArcBlock's ABT node is actually a really powerful combination for really for any developer or project. We couldn't be more excited to be working with AWS on this and providing some additional backend solutions inside of the ABT node to support additional use cases, especially around the use cases that Lana mentioned there. Whether it's banking, it's finance, anything related to high transactions. It's a great way to support those. In addition, you also have the ability with ArcBlock's ABT node to run the database and blockchains. So there's quite a bit of flexibility there. So at this point of the session here, I'm going to give Jonathan just a minute to get himself ready for the next talk. But kind of going back, and I think anybody who's been around ArcBlock for a while now knows that one of the key ingredients for ArcBlock's platform and really working within blockchain projects and solutions is decentralized identity. So ArcBlock has spent the last 2 years really working hard to integrate support of decentralized identity capabilities throughout our entire platform, following the leading standards from, for example, the W3C. So ArcBlock is part of the Decentralized Identity Foundation. We are part of the W3CCG, and really working hard to number one, follow the standards, but number two, and I think more importantly, is really make it very useful and practical so that people really can work with decentralized identity and also what we call DIDs to leverage those technologies for your own applications and services. So for anybody who's interested, of course, you can actually look at our own identity protocol online. You just go to Google or go to Bing and do a search for ABT DID protocol, and you can actually take a look at our entire specification, the methods that we use, how we generate the DIDs and whatnot. So during this next session, what we're going to do is ArcBlock's team, and specifically Jonathan, is really going to look at decentralized identity and show you how to leverage decentralized identity into your own project and maybe enable your app to support a wide range of brand new use cases that really without decentralized identity just weren't possible. So we're going to go ahead and dive in and do decentralized identity like Jonathan is already.
Hello everyone, my name is Jonathan, and today I'm going to show you how to integrate your application with decentralized identity. And in the upcoming 40-something minutes, you'll be expecting to play with some of our products, and then also get your hands on to write some simple codes in order to get an application up and running. All right, so let's get started and see what's right. So this talk or this workshop will mainly be focusing on integrating DID experience into your application, and to ask a question. It's like, what actually is DID auth, and how does it look like in the real world? And to answer this question, I guess we can go and look at a real demo, and which is the ArcBlock website for this Devcon. All right, so as you can see here, in this Devcon website, we actually have a login button on the upper right here, and we'll see. Let's see what happens if we click here. So it will pop up a model, and then with the QR code, and ask us to basically like sign into this application. And let's see, right now I'm going to put up my my wallet on the phone in order to let you see what's happening on the mobile. And okay, so right now you can see on the right hand side is my phone, and I have a QR code scanner. When I tap on it, I'm going to like scan the QR code here, and I'll get the login request on my phone. It says it's an application called Devcon 2020, and then it's asking me to provide information like name, email, and profile picture in order to log in. If I'm okay with it, I'll just slide to confirm. And as you can see, login successfully. The model is dismissed, and on the upper right, where used to be the login button, it actually shows my profile picture and my name on it. All right, so this is basically what it looks like if you integrate this DID experience to your application, so that when your user is going to log in to the to your app with their decentralized identity. This will be the whole user flow, like scan the QR code and slide to confirm it, things like that. All right, so let's go ahead and see what's actually needed to make this happen. So if you want to build your own DID auth experience, what type of components you need? So first of all, you need ABT wallet. Your user will need ABT wallet as well, because they need to use the wallet to manage their decentralized identity, and then use the wallet to scan QR code and log into your website. But on the other hand, as the developer, you also need ABT wallet, because during the process, you're going to use the wallet to help you create your application, and also set up your node and things like that. So a lot of things you will be doing using the wallet. And then the second thing is ABT node. You probably have heard from other talks that ABT node is at the very core of the whole ArcBlock framework and ecosystem. So it serves as the base layer for everything. And on top of that comes the blocklets, which will be the building blocks for building decentralized applications. And it's up to the developers' choice to pick whatever they need and then put them together, and then deploy them on top of the ABT node and build their own decentralized applications. And so for this DID auth experience, what the blocklet we'll need is the DID Connect blocklet. And this is something that's similar to the Facebook App Center or Google App Center, where you're going there. If you want to build a Facebook or Google login experience, you're going to the App Center and then create an application and stuff like that, and then use the information or credentials provided in the App Center, and then use the integration guide or documents, whatever, use those things to integrate your application into the login experience. So basically like that. And at the end of the day, you have to write some codes. It's very simple, but you have to write some. And all right, so let's see. I'm gonna give you a short intro of ABT wallet. I guess during some other talks, my colleagues, they already have shown you some basic, more in-depth introduction of ABT wallet. But here I'm just going to go over it real quick. So for ABT wallet, it's a decentralized wallet and helps users manage their identities. And also we have two layers of security. One is a mechanism of password to help you protect the data during the whole usage. But once the wallet is lost or something like that, maybe your phone lost or whatever, if you want to recover your wallet, you will be able to use the password and the backup file to do a full recovery. But if you don't have the recovery file or backup file, you can use the recovery codes to do a partial recovery and to get your root key pairs back from the recovery codes. And then related to login experience, the wallet actually separates user profile and identities, so that you will be able to submit your profile, whatever profile you like during the login request. So your profile is not like entirely connected or linked with your identity, whereas for some other services you're pretty much linked with each other. And also for wallets, there are a bunch of other things you can do, like browse the decentralized applications and use them in the wallet, and like send transactions and receive tokens and stuff like that. But that's way beyond today's this workshop scope. So I'm going to just like give you a short walkthrough here, and you will see for the wallet, it has a cards tab, which is like listing all the accounts, and later on, if you have any assets, you'll be listing here too. So each of these cards is actually one of your accounts, and then every account is actually backed by a DID. As you can see here, it's like Z1MU and IMNB. So this is the DID of this account. And for here is the profile. And for profile, it's actually served as a template of your personal information. So we saw when we scan a QR code and then it jumps up and then asks the service or the app may ask me to provide some information. This profile is preset, prepared, so that I don't need to type in any profile every time I try to log in. But I'm free to change the profile I'm gonna use every time I try to log into the same service and things like that. So it's like not totally linked. And other than that, it's basically okay. We have a tab here for you to see what app you've been used and be able to use the app right in the wallet. And I don't have any transactions yet, so you'll be able to look at the transactions you just made. So this is a quick intro of and walkthrough of the ABT wallet. So now let's move on to ABT node. So one prerequisite is that you have to install Node.js in order to install ABT node, because the ABT node is depend on Node.js. If you haven't installed it, please install it right now. And like I said before, ABT node is the base layer for the whole ArcBlock ecosystem. And on top of the node, it actually serves the blocklets, and the blocklets are the building blocks for decentralized applications. And the whole node is actually running on a web-based interface. So at the very beginning, you have to use command line to kind of install the ABT node software, but after a few commands, you'll be able to just get rid of the interface and then use the web interface to do everything from there. So let's try to set up an ABT node for now, and let's see. Let's go to the terminal. All right, so installing ABT node software is actually pretty easy. So it's a npm package. So if you want to install it, you just install like npm install g global for ABT node CLI. So what this would do is to get the ABT node software and then install in the local machine, and also it has some like command line interface or a few commands that you can use to initiate a node and start a node and stop a node and things like that. But once you configure the new node, and also once you start it, you can just switch to the browser to do whatever you want with the node. All right, let's wait for the installation. All right, it's done. And then what we would need to do is to initialize the node configuration. So I'll do abt node init. And I'll just go with the default, everything default configuration, and just to get it quickly up and running. So now after like configuring it, and then what we need to do is just like abt node start. And this will actually launch the node, and from now on we can turn to the browser and then see and then continue the operation there. Right, so now let's go to the link of the apt node. Okay, so here, like I said, you have to use your abt wallet during the process sometimes. And this is when you're trying to set up a new node. You have to tell the node that you are the owner of the node. And in the future, if you want to install some paid blocklets, you'll be able to do so because you're the owner of the node, and if you previously paid for that, you'll be able to download and install that blocklet onto this node just because you're the owner. And let's see. All right, let's try to scan that QR code here. And we'll just go with it. And now I'm, as an owner, is connected to the abt node, and I'll complete the setup. And now I'm going to the dashboard. Right, so this is the dashboard, and in the dashboard, the overview part will be a bunch of like basic information of the node and stuff. And more importantly, we'll be able to go to the marketplace and install blocklets, and which will let us have more capability to build a decentralized application. All right, so right now we've been we've finished setting up the abt node. So next up, we're going to play with the DID Connect blocklet. So there's a prerequisite here, which is installing MongoDB, because like the DID Connect service is actually some sort of app center for creating applications and stuff. So there are a bunch of informations that the DID Connect service needs to store, and this is where the MongoDB comes in. So if you haven't had MongoDB installed yet, please install it right now, and we're going to use the MongoDB URI later in the process. And so DID Connect is a blocklet, which could be installed from the marketplace. And after installing it from the marketplace, we can start the blocklet, and the blocklet itself is also a web app. So you'll be able to go to the web interface of the DID Connect, and then do the app creation and configuration and stuff, just like pretty much like what you would normally do in Facebook or Google App Center and things like that. So an important nature of the DID Connect and running on the abt node is that you'll be able to deploy your own app center. For example, if you're managing a bunch of applications and you don't have to rely on a third-party app center or DID Connect service to help you manage the applications, and you'll be able to like just deploy the service for yourself, and then manage the application and all the configurations and stuff. This is in contrast to what we normally do with Google and Facebook. Like if we want to create a Facebook app and Google app, we have to go to their app centers. We cannot host our own app center to help us do the things. All right, so let's try to set up our application in DID Connect. Let's see. Okay. Now in this marketplace, we can see DID Connect is here, and we're going to install the latest version of DID Connect. So right, DID Connect is installed successfully, and let's go and open it. So here we are actually we actually installed the DID Connect software, but the reason why we can't start it at the moment is that we have some configurations that's not done yet. So which is this is where the MongoDB comes in. So if you have MongoDB set up, you can have the value filled in here. So it's like MongoDB and your MongoDB address or URL, and then the database name will be DID Connect service. And once we save this configuration, we'll be able to run DID Connect service. So let's go ahead and start it. All right, so we've already started, and so we have a public interface for DID Connect, and if we click on that, you will be able to see this DID Connect service. So right now we have, so previously I've been logged in, so let me try to log out and do it once again so that everybody knows what it's like to the initial experience. So all right, let's go. Let's see here. Okay, so right now what we will do is to like log into this DID Connect service. So it's the same experience as what we had before, log into everything. So it's like as a developer, I'm logging in to this app center, and then now we can create a new application as a first-time user. We'll just call it demo, and this is a demo. Right, so we can create an application, and upon creating an application, sorry, I think my streaming is lost again, so I have to do that one more time. Bear with me, please. And right, so now I have to scan the QR code again because in this stage I'm actually creating an application. So instead of letting DID Connect generate the key pair for you, you're actually, as a developer, using your own wallet to create a key pair for the new application and generate a new DID for the application. So so that in the future you have full control of your application. So here I'm gonna confirm, and then now the demo app is actually created. So here we saw a login component. We just let it start, and then having it started, there are a bunch of configurations that we have to make. So the first thing is the login message. This is where you can show some custom message to your users that upon login. So to ask them to log in. So I'll just go with please log in to the app, and I'll choose full name, avatar, and email, and I'll save changes. And for saving the changes, I'll scan and use the application DID and key pair I've just generated to sign the message. So the last step is to kind of like enable the login experience. Right, so this login module has been configured, and now we can move on to writing some codes to try to let the app connect to the DID Connect and have that login experience. And actually, before we jump in right into the code, we have one more thing to kind of configure. It's so right now in the integration tab we have like web integration and stuff and OAuth integration. So today's example, I'm going to use the React.js and use the web to build a web app to demonstrate. So for here we have to set up a domain whitelist. What is a domain whitelist? So basically, if you're running an web app and then you're sending requests to the DID Connect, and then say we have a user trying to log in, and DID Connect will check the domain whitelist to see if the web app's domain name is actually in the whitelist in order to protect the security of the user and also for the application. So this is something similar to what Facebook and Google would have. It's like having your domain name for your application, just for extra layer of security. So for development purpose here, we just give it a star, so that it gives access to every domain. And now we probably can start to jump to the codes for now. And right, so let's go back to terminal, and all right, no, let's go back to slides first. Sorry about that. So for for the next step, we're actually going to write some codes, and the process of writing. So the things that we need to do in the coding part is several things. So first is to create a React app, and then we need to add DID Connect dependency to the application. And also the next step is to configure DID session provider. It's actually a wrapper of a React app that makes it depend on the session login section of the user. And also the next step is to get the session context from DID Connect and dependency and see if there is a valid session. If so, we're gonna show the user's information, like the avatar and name and stuff like that. If not, we're gonna show a button allowing the users to log in with DID Connect. And lastly, we need to specify the service host and app DID, which is like telling the React app where to connect and what's the ID of your application, so that when you send a request to DID Connect, it can verify the application's identity and then move forward to process the login request. And last, we can run and see how it goes. So let's do it. Right now we're gonna switch back to terminal, and the first thing we need to do is to create a React app. So it's like npx react it's like we create React app, and we call it like just like my app. So it's gonna take a while, and you guys can also do that. And if you already have some React app template that's you already generated before, you can reuse those. But it's gonna take a while to install the dependency and stuff like that. This actually might be the most time-consuming part of the whole coding and development process. All right, so it looks like finally we're done with the installation of the React app. Let's see, right? Okay. So right now, what we're doing, what we need to do is to add the dependency to the project, which is the DID Connect package. So we're gonna add it for here, and after installing the dependency, we can turn to coding and see and see what kind of codes we need to write. All right, so right now we've done adding the dependency and stuff. So let's go to the code and see what it is like. All right, so I guess this is it. So we have we have to actually go to okay. Right, so next up what we're going to do is to change a little bit of the codes here. So right now we don't need the service worker, we just get rid of it. And what we need to do is to when ask the React DOM to render render something that's like a wrapper of the React app, and the wrapper will be able to like get the session information using DID connect package dependency. Right, so what we need to do here is first to like import the dependency, like DID DID session provider. We need to add it here. And then what we need to do is to add a wrapper of the application. So this wrapper application would initialize a DID session provider and then wrap the whole React app inside this component. And then last but not least, we're going to ask the DOM to render this wrapped app. And next up, we're moving on to app.js. And then here, what we need to do is to first, we need to import some dependency, which is the DID session context. And also we need to the use context from React. And then we need to initialize the, we need to get the session status from the context for the application. And then and then we will need to set up a session markup, which will be the elements on the web page that we generated depend on the session status. So we'll see, we'll add this code here. So the logic here is like if the session is loading, we'll show the message of like initializing the session. And then if the session is finished loading, and then we'll check if there's actually a user logged in already. And then if so, we'll show his profile picture and his name and stuff like that. And then provide a link for the users to click to log out. And if there's no user logged in, the markup will be like you're not logged in, and then click on a button to try to log in. And then we'll need to add the markup, kind of like render the markup into the application. So in the application component, app component, will return the session markup here. And the last thing to do, if you guys still remember, is to specify the app DID and service host. As you can see here, it actually triggers an arrow because we haven't specified them yet. So we need to pass on these two parameters to kind of like initiate a DID session provider. So for here, we'll be able to get the session ID from the web, the integration guide here on the DID Connect service. We'll just copy them here and paste them here. All right, so this is quite simple, and everything about codes are already done here. And let's go and try run the application. Right, let's switch to the browser and see what's going on there. Okay. All right, so the app is actually building right now, and let's wait for the React app to build. Okay, so it's there, and oops, let's log out first, and so hang on a second. Sorry about that, guys. Okay, so I'm gonna switch to here. Okay, so let's see how the codes work in action here. So as you can see here, we have a login button, and if we click on that, it will pops up the QR code, which will be something familiar to us, I guess. And then right now, let's go and scan the QR code. And for now, if you can see on my phone, it actually shows a login request. That the request is from a demo app, and it asks for the information that I just specified on the DID Connect website. So it's like name, profile picture, and email. So if I go ahead and slide to login, right, so it's, oops. Okay, let's try it again. Okay, so now I'm logged in, and then I have my name here, my profile picture here, and then if I go back to the DID Connect service, if I go to user, I'll be able to see there's a user logged in happening just now, and I'll have a log of my login there. So in this case, the DID Connect has already been integrated. All right, so not sure have you guys been following that, and it's quite easy actually. So all right, so let's wrap up. For the coding part, you just have to create a new React app and then add the dependency of DID Connect to the React app, and then configure the DID session provider and use the session context and specify service ID and app DID, and you're good to go. So this is like a very basic DID login integration for a web application. And for more capability of DID and DID auth protocol, we'll have a website deployed here. It's a Wallet Playground, and there are a bunch of like test cases that you can go and play with. It's like a transfer money and a cross-chain scenario and stuff like that. So you'll be able to experience and find out more about DID capability other than like authentication and login. All right, so thank you for joining this workshop today, and let's see if you guys have any questions and stuff that I can help with. Thanks for joining.
All right, thank you, Jonathan. So it was great to see decentralized identity in action, and in fact, we saw a real application being built there during that session. And I think one of the things that you can take away from the session so far today is that ArcBlock's goal is to really give developers better building blocks for blockchains to create and deploy and manage modern blockchain software. So what we're going to do in this next session is actually bring it all together, and we're going to go ahead and ArcBlock's engineers are going to put together a blockchain-based game. And we're going to go ahead and get that session started here in just a second here. Just checking to make sure that the team is ready to go. So what we're going to do is build a real game here during this session, and this is something that you'll be able to do yourselves. So let's go ahead and get started.
Hello everyone, welcome to our blockchain workshop. In this workshop, we will give you a step-by-step guide on how to build a blockchain game with our Forge SDK. And please get your laptop or computer ready before join this workshop. Here is the agenda of this workshop. First, we need to be clear about the basic requirements to participate in this workshop. Then we will walk through our game design and the basic background knowledge. We will describe what the game will look like and what are the business rules in the game. Next, we will set up our wallet playground in the AV node, which is an awesome blocklet that can demo many features of our APT wallet and other ArcBlock technologies. Then I will guide you through the bootstrap our game app with our sample project. Then we will start our Visual Studio Code and implement the planned feature in the app. Finally, we will get our game bundled and published as a blocklet. Now let's start. First, for the basic requirements, you need to get your local APT node instance up and running. If you have you haven't done this, please refer to our previous talks and workshops for how to do this. And second, you need to have ABT Wallet installed and set up on your phone. Ideally, you should have your phone connected to the same network as your laptop. Third, you should have some basic programming knowledge, and you should know basic command line operations. Third, then it's better you can write some code with JavaScript, and it's better you know some React, because the game dev will be built using JavaScript and React.js. And lastly, you should have MongoDB up and running. If you do not have MongoDB installed, you can install it with brew install MongoDB. And the MongoDB is a required database for our wallet playground and our game. And that's all for the basic requirements. If any of these are not ready, please take your time to get them ready. Okay. And then for what we will be building in this workshop, it's a simple game. This is a screenshot of the UI part of the user interface part of the game. It's a simple. This is a classic game called 2048 that users combine tiles on this grid to achieve higher scores. And this is the score of the current game the user has achieved, and this is the balance of the game coin of the current user, the player. And this button should be disabled if the balance of the game coin is 0. And once the user have bought more coins, this he or her should be able to start a new game. And this button is used for buy more coins. And this is the UI part. And for the business logic rules, here are the simplest. First, we provide a simple game that user combine tiles to achieve higher score. And the user need to log in with ABT Wallet to play the game. And the user need to pay game coins to start a new game. And the game coins are bought with native ABT token. Ideally, if this game is running in production, thus the game developer can get paid if the game become very popular. And what's more, if the user has achieved a higher score on record, such as he got a score like 1024 or 248 or 696, 1396, he can get a unique badge that he can show off, and he can save that badge in his wallet. Okay, and to make the feature of the game become reality, we will leverage a few capabilities of our blockchain framework. The first one is atomic swap. Since our blockchain framework is built with the purpose to allow developers to start their application chain easily, we need to that's common for different chains to move data from one chain to another in a secure way. And that's why atomic swap is born. Atomic swap is a way to move data across different chains securely. And the word move here means the tokens and assets can all be moved, or we can refer this action as swapped. And for the SDK support, our GetIOS SDK has built-in support for automatic swap handling. And in our game application implementation part, I will demo to you how to use this library to handle automatic swap with empty wallet. And another background knowledge is non-fungible token, which is also called NFT. No matter you admit it or not, almost everything will be digitalized on blockchain or somewhere else. Most of them are digitalized on our current internet. The most common use case for blockchain is for tokens or coins, but anything that's not a token can also be stored on blockchain, and they are called non-fungible token, such as our certificates, badges, or tickets. They can be saved and displayed in empty wallet, and they can be transferred on our blockchain. And for the SDK support, our NFT, we also have a standalone library to allow users to create non-fungible tokens easily on the blockchain. And in the later of the workshop, I will demo to you how to use this lib to create high score badges for users. Okay, then let's move on to the for the features we need to use in the game. We should first set up an awesome blocklet that's called Wallet Playground, and play in the blocklet to see what the atomic swap and NFT will look like. And to set up Wallet Playground in our apt node, we should first install the blockchain manager blocklet and set up a local chain and a foreign chain. Then we need to set up the blockchain explorer. Then we need to set up the Wallet Playground. Now let's move on to set up our Wallet Playground. I have running apt node here on my local laptop, and I have already installed our blockchain manager and the blockchain explorer blocklet. And all of the blocklets are running. If they are not running, please get them started by click this button. And to start, we need to create two test chains on our local with our local blockchain manager. Click this button and name our first chain as the local chain, which will be the chain where our game chain, where our game coin will live on. The token name, let's name it as the game coin, and token symbol, let's name it as play. Then let's scan the QR code with our apt wallet to create a blockchain moderator. Okay, then let's hit the create button and wait for the chain to create. Then we can start the chain. The start may take about 10 or more seconds to complete. Okay, then let's create another chain called foreign chain. The token name is named native APT, and the token symbol is let's name it as TBA since it's not exactly the same as ABT. Again, we need to create a chain moderator for this foreign chain. Create. Okay. We need to make sure both the foreign chain and the local chain are running. Let's duplicate this table because we need to set up these two chains in our block explorer. Let's open the public interface of the block explorer. And then let's copy the GraphQL endpoint of the two chains and add them to the network list of the blockchain explorer. Let's use our internal IP here. You should use a different IP on your local networking environment. Then we need the GQL endpoint of our another chain. Okay. Okay. The foreign chain and the local chain are both added, and let's switch to the local chain and block and explore the blockchain with the block explorer. There are no transactions here. Then let's move on to install our wallet playground from the marketplace. Okay, then we need to open the wallet playground. The wallet playground requires a MongoDB connection string to start. We need to get one. Let's click the edit button here and paste in the connection string, wallet playground apt node. Okay, because we want the wallet playground to connect to the two chains we just created. So we need to add 4 more environment variables for the wallet playground before we start it. First, we need to set local chain ID to local chain. Then we need to set local chain host to let's copy the link here. Again, we should use our internet IP here. Okay, let's copy this for later use. Again, we need to add foreign chain ID as foreign chain and the foreign chain host as 8106. Okay, all the configurations are there, and then let's start the wallet playground. it may take minutes for the wallet playground to start, since the playground pre-start hook is doing a lot of work. First, it needs to declare itself using this blocked FSK on the two chains we just created. Then the script will collect tokens to the playground wallet playground account for user to play with, and we can check out the transactions here. These transactions are all done by the pre-start script hook of the wallet playground. I think now our wallet playground is up and running. Let's open the playground and log in. Use our ABT wallet. First, this is a mini page of the wallet playground. On this page, we can claim tokens for test. First, let's get 10 native tokens TBA from the wallet playground account. When we refresh our wallet, we can see that our balance has changed. Then we can get 20 play for later use. Okay, here we are. Maybe you are wondering why we have so many tokens here. That's because the blockchain manager, when we created the two chains, we have generated the key pair of the blockchain moderator of each of the new chain. Thus, the token of the blockchain are all in the moderator account. And for the wallet playground account, it's here. This is the transaction that we just got 20 play token. And because in our game, we will let users to buy the play coin, with TBA token, TBA coin, and this is we can use this button to test. When we click this button and this is the swap screen. On the swap screen, we can see that we will send one TBA and we will receive around 20 play as a result after the swap succeed. Now let's confirm. Okay, after the operation, we can see that the TBA part is the TBA balance is updated, and our play balance is also updated. And this is the atomic swap record that we just generated. Okay, this is the feature needed for user to swap their native ABT token for the game coins. And there's another feature for in the game that requires user to pay game coin to start a game. This is a button to achieve that. When you click this button, let's use the play token. When you click this button, you will be asked by the DApp to pay 10 template to unlock something or to buy something. Okay, our balance is also updated. And for the NFT badge part, for the badge, we can open the full list of our wallet playground, which have tons of features for you to play with. Let's use this for a test. Because the badge test kit is broken, we can just test with our ticket part. We can get a ticket for free when and this is a preview of the ticket. Let's slide to confirm. And then in the wallet, let's refresh. Then we can see the ticket is there. And in the game, when the user has achieved a high score on record, we will give him a badge. A badge will look like this. Very similar to tickets. And I think that's all for the wallet playground demo. More features are here for you to discover. And next, let's move on to Blocklet bootstrapping from our starter project. Okay, now let's get our hands dirty by implementing our Crypto 2048 game. First, we need to bootstrap our project to make all our participants easier to start. I prepared this repo as a starter project. From this project, you can clone because this is a public project, so you can use HTTPS. Or you can fork this project and clone from your own account. Since I am the owner of the repo, I can clone this repo. Just with git. Oops. Then after the clone succeeds, we need to install the dependencies. I am using yarn, and you can also use npm install. So, oops, I forgot to switch to my repo and yarn. Then we need to create a .env file. The file content should be like this. And later I will walk through the key paths of this file after we have successfully installed the dependencies. The dependencies may take some time to install, depends on your network. Then we need to touch the env file. Then let's open the current directory with our Visual Studio Code. Let's open this file and paste in the configurations. There are a few very important configurations here. For the Mongo URL, this is the connection string of MongoDB. That you can change to a running MongoDB instance. And here are the chains that this game should connect it to. The config can be divided into two chains. The first chain is the local chain, which is where the game coin lives on. I have configured it to point to my local chain started with blockchain manager. You can see it from here. The local chain 8105, and the other one is the foreign chain, which is where the native token lives. The port is 8106. And another important side note about this is that you should change this IP address to your local address, and this one. All these should be the same. Otherwise, you won't be able to run the app local successfully. And another important config is the app ASCII, and you should not change this. If you know how to do that, you can do that, I think. Let's save this file. And then we need to do some preparation for the app. Let's run a script from the repo. This script helps us declare account on the two blockchains. This is because on the local chain, our game account will be able to sell game coins. So there must be account. And on the foreign chain, our game must have account to receive native tokens. So it should have account on both chains. This script helps us do that. If you are curious about what this script does, it's here. It's just send to declare transactions with Forge SDK. And then we should fund our game account with some game coins from our ABT wallet. Let's demo to you how to do that. Let's come back to the ABT node and open our blockchain, the public interface of Blockchain Explorer, and fill in the two endpoints, GraphQL endpoints of the two chains, of the local chain and the foreign chain, and let's switch to the local chain. And from here, let's find our game account. The account address is here. Let's search for it. Okay. And if you for the account balance, you can see that it's more than 0.1 billion. So we don't need to fund this account for later operation. If the account balance is 0 on your local chain, you should do click this button and scan the QR code with your ABT wallet and click transfer and transfer like 10,000 play from your moderator account to this game account. The transfer should be confirmed very fast. That's it. And another preparation work we need to do is get a native token account. That's where the blockchain boarding gate comes into play. We can provide its GraphQL endpoint here, and then click choose blockchain and scan the code. and then get some test token, although it's not required. I'm getting this error because I already did this. Okay. And you can check the native token account from here. The balance should be 25. Okay. And the preparation is done now. Then let's get to the actual coding. The game implementation. The first feature we want to implement is the game call buy-in process. The basic business rule here is that one native token can buy 100 game coin. Before we implement this feature, let's do a simple walkthrough of the current code base. You can start the app backend by run start server, and then start the front end by start client. And then let's create a new tab for other stuff. Let's wait for the first load of the app. I may need some cleanup here. Okay, the game requires us to log in with our APT wallet. Thus, it can charge us from our APT wallet. Let's log in first, and this is the game. Because my game coin balance is 0, I can't start a new game. The first feature we will be implement here is the game call buy-in process. First, we need to install our two dependencies here. Let's run yarn add ArcBlock DID auth and ArcBlock DID React. Okay, the dependencies are there. Then we will do to add code to the code base. We need first do a simple walkthrough of the code base. The game contains two critical parts. One is the front end part, which is bootstrapped with create React app. This is a simple React application, as you can see from this file. And the backend part, it's a simple Express app, as you can see from here. And it's using MongoDB to store data. Okay, and the current login logic is here. It's in the API routes auth folder. And it's using the DID auth library already. The routes is loaded here. For the game call buy-in feature, first we need to implement the backend handler. Since this process requires connecting the APT wallet, let's create a new file called swap.js, and let's put the backend code in that file. This file is importing the swap storage part from the libs auth file, and it's exporting an object that can be consumed by the swap handlers. Swap handlers is defined here, swap handlers. And from here, we can tell that this handler wants the wallet to do a atomic swap, and the basic parameters are here. We are offering game coin. The default game coin amount is 100 game coin, and the exchange rate is 100, so that for the user, he need to provide one native token to get those game coins. And then we tell the wallet to set up swap. And after having the routes ready, let's import the routes here. And let's use swap. Okay. And for this, this is the backend part. And for the front-end part, we need to have a button on the index page. First, we need to add the buy coins button. And when user click on the buy coin button, we will be pop up a QR code dialog, and let's add a flag for that state. The swap open is a state that indicates whether the QR code dialog is open or not. When the user clicks the button, it's open. But before it's open, it's creating a new swap order that can be used to trace the whole process. And once we have the swap open set, we can open our typical library, typical DID OAuth dialog. The OAuth is using the most important parameter here is the action, which is set to swap, and it must be the same as this one. And then there are swap close or swap success, and this is also an important parameter here. It's the swap trace ID, and for the messages, after you can tell where are they displayed when we test the feature. Okay, let's go back to the test. When we click buy coins, we are prompted to do atomic swap. The swap said we will receive 100 play, which is 100 game coin, and we will send 1 TB, which is 1 native token. Let's select to confirm. Okay, the swap should be complete within 10 seconds or so. Then our game coins should be there. Now we can start a new game. But the start new game will not charge us now. The charging part is what we will be implementing next. Okay, it's working. Next, let's implement the authorization part. For the payment part of the game, if we are just using the transfer, each time there are two ways to do this. The most simple one is when the user click new game, we pop up a dialog that asks user to transfer two game coin to the game. Then we will give him a new game. But this is not the best user experience. With ArcBlock blockchain framework, we can achieve better user experience with something else. Maybe you are very familiar to some e-commerce websites that you add a credit card. Then when you buy something, you are automatically charged from that credit card. and with our blockchain framework, we can allow user to authorize the game to charge when the user starts new game, and the authorization is sent by the user and it's saved on the blockchain, and so it's auditable and it's public verifiable. And to implement that, first we need to add 2 more dependencies. One is the TX util, the other is DID util. Let's wait for the dependency to be ready. Similar to the swap part, first we need to create a new auth route here. Let's name it as authorize.js. And let's put the content here. Then let's have a quick walkthrough of the code. This code, we are using verified TX and to delegate address from the util labs. And we are also exporting a object that can be consumed by our DID auth library. For the claim part, we are asking the user or the ABT wallet to send a transaction. The transaction is a delegate transaction. The delegate transaction is delegated to the game account. The wallet is the game account, as you can see from here. The wallet, it's generated from the environment app key. And the ops, the allowed ops on this delegation or authorization is that the game account can do transfer when the transfer meets the following rules. The first rule is the transfer value should be only 2, should be equal to, and the transferred assets should be empty. Thus that the game account cannot move any assets from the user. And the transfer to should be only point to the game account. And when the ABT wallet has sent the transaction in this callback, we will send the transaction with Forge SDK. And this is the backend part. We also need to load this route here. And then let's implement the front-end part. For the front-end, we also need a button to allow user to send the authorization. And when user clicks the button, there's also a flag to set the auth pop-up QR code be open. And then when the pop-up, when the auth pop-up is open, we should render that pop-up. And the action parameter points to the authorize. I think that's it. And let's try the authorization part. Let's scan the QR code and select to confirm. The delegate details are not fully rendered on the ABT wallet. Okay. For the delegation, we can see it from here. And the delegation is from the user account to the application account, and the delegation state is here. We can see that the rules are here. Each time it can transfer 2 tokens, cannot transfer assets, and can only transfer to itself. Okay. And the authorization part is done. Then let's do the payment part. For the payment part, we need to also add a backend API for starting a new game. In the API, we should charge user for 2 game coins. And on the front end, we should hack the game start stage. In that callback, we can call backend API to start the game and disable the start new game button and show a loading indicator when calling the API. And we should refresh the game coin balance when the user is charged. Okay, now let's move on to implement the actual payment part. First, we need to add a route. It's not an auth route here. Let's name it as game.js. And it provides a simple API that's used to start the game. We will check the user from the current request, and the user is decoded. As you can see, it's decoded from here. We are using bearer tokens for authentication, and then when the user exists, we just do a simple transfer. The delegator is the current user. Token amount is 2, and memo is start new game. And then we will wait for the transaction to be confirmed, and then we will return the transaction hash to the front end. And then after the route is ready, we should load it here. And on the front end, the proper way to hijack the on-game start is we add a on-game start here as a property for the game component. And the actual on-game start, let's just get the preparation code. We are calling the API defined here, and if that succeed, we will refresh the session, which includes the current game coin balance, and we call the callback. Otherwise, we call the callback with error. And if you look closer at the game component, we can see that we have a game start here. If the parent provided a game start callback, then it will set itself to state loading, and then it will call the callback. And if we have error, it will render the error. Otherwise, it will init a new game, which the new game is not empty, so that it can be played. So now let's try the charging part. Since we have done the authorization and we are calling the new game. Okay. The game coin balance is updated. Let's try again. Okay. Let's try again. Seems works. Cool. And when we come here to the block explorer, we can see that there are 3 charging transactions and the memo is here. Okay, the charging part is done. Next, let's implement the achievement badge part. And for this part, we are using the NFT library and NFT template library. The basic business logic here is when user finished playing the game and he is getting a score higher than our threshold, we can allow him to claim a trophy. And this also requires a backend handler and requires we hijack the onGameOver on the front end. Then let's do the work, do the coding. We should first install the new dependencies. First, we need to add a new auth route, which is called trophy. Let's do a quick walkthrough of this code. We are importing the NFT factory from our NFT library and NFT recipient, also NFT recipient from there. And we are importing the trophy template, which can be found here. This is a simple SVG. And we are creating a new factory instance so that we can use this instance to create a new badge. In the badge, it's displayed as a trophy, visual trophy, and the trophy display is created from the SVG template. And the recipient is set to the user ID. And this is the trophy creating part. And for the trophy claiming part, when the user wants to claim the trophy, we will generate one dynamically and ask user to send the trophy address. Each trophy has a ID. And before user send, he will see a preview of the trophy. And when the user has sent the trophy address, we will simply transfer the trophy from the game account to the user account. And this is the backend part. Let's add it to the let's load it in the backend main file trophy. Okay. And for the front end code, we should first hijack the onGameOver. We should first have a state called has trophy. And we should also then have a callback on onGameOver. And when the scores is larger than 1024, we can allow user to claim the trophy. Then let's add the onGameOver to the game component. And then if we can claim the trophy, we will render a button that when the user clicks the button, it can open the trophy dialog. Let's add another flag here. And then add two more methods to control the flag. And then when the trophy pop-up is open, let's render the pop-up. Yeah, let's put it here. The action parameter points to the action here. Please remember that. Okay. Now let's test this feature. Normally we start a new game and our game coins get charged. Let's say if we can score up to okay, game over. Now we have the claim trophy button. We can claim the trophy. Let's scan the QR code, and from here we can show the we can see the display preview of the trophy. And let's refresh the trophy list. Okay, now it's there. And if we click the trophy, we can see that we have a trophy from Crypto 2048, and the trophy name is Crypto 2048 Master, and our DID is in the trophy. And I think that's the point of NFT, blockchain NFT. Okay, up to now, all the features of the game has been implemented. Now let's move on how to make this blockchain game blocklet. First, we need to initialize the blocklet's required metadata and documentation file. You need ABT node installed by performing this operation, blocklet init. Then let's answer a few questions. Demos capabilities of ArcBlock technologies such as blockchain, DID, and ABT node. It's a DApp blocklet. Let's choose primary. Yes. Okay. Now it has generated the blocklet.json and blocklet.markdown file, and let's add more fields into that file. First, we need to add main. Let's close all the open files and clean up. Let's add a main here. It should point to api/index.js, and then let's add a provider. It should be Devcon, and then let's add public URL field. It should point to our root path. Then as we clarified in the beginning of the coding, there are 5 important configurations for the app. We should add another array of required environments here. Let's copy my prepared environment settings here. These settings are Mongo URL, local chain ID, local chain host, foreign chain ID, and foreign chain host. Okay, I think that's all for the blocklet metadata. Next, we will need to add a few scripts that can be used to bundle the blocklets. First, we need to add those blocklets, those bundle scripts into the package.json file. They should live here. Let's copy them. We have 3 commands here. This is an aggregation command that will run all the bundle commands. We need to bundle 2 parts of the application. The first part is the SRC, which is the front-end part. The second is the backend, which is the API folder. The front-end part is bundled using the React scripts command line. We need to provide 2 important environment variables. The backend part is bundled with apt node. We can just bundle it with apt node bundle. And besides that, we can test our bundle scripts here. npm run bundle. This may take some time to complete. Well, it's still bundling. I think we can move on to what we will do next. Next, we will be doing the deploy, which will deploy the blocklet to our local apt node. Let's check whether it's finished. Looks it's taken more time than expected. We can continue to add more scripts to prepare the deploy while we are waiting. Now it's bundled. Our bundle scripts is okay. The next step is we prepare for the deploy, in which we should consider what hooks will be needed when make the blocklet run from a standalone environment. From the beginning, we are clear that we have 5 critical environment variables that need to configure. But before if you can remember, before we actually start the app, we did 2 things. The first is we declared the game account on both chains. The second is we transferred some game coins from the chain moderator to our game account. And this is also required when this game app is installed in a new apt node and running from there. So we need to add a pre-start script. The script will do the account declaration and funding work. Let's create a new folder under API named hooks and create a new file called pre-start. Okay. Then I will just copy a prepared pre-start script here, and let's do a quick walkthrough. The main entry point of the script is here. It will check the environment variables. If we have chain ID, we will ensure that the account is declared on that chain. and the account state is there. And we will also ensure that the account is funded. And for the asset chain, we did the same thing, but we don't need this. For the account declare ensure code, we can see that it will check account state. If it's not there, it will do the declare. And for the funding part, it will check for account balance. It's less than 250. It will do generate accounts randomly and poke in those accounts, and then transfer from those accounts to the game account. And then we should configure the hook file here. Pre-start node API hooks pre-start.js. We also need to tell AP node bundle that we have hook files to bundle. This should be an array. Okay. And to make things simple, we can add a pre-deploy script here that does npm run bundle. Then let's try apt node deploy here to see if it works. This may take some time because we will be rebuilding the whole blocklet, both the front end and the back end and the hooks. While we are waiting for the building and deploy finish, we can look further on the publish part. For the blocklet publish, there are 3 steps. First, we need to update the publish config. Then we should publish the blocklet to the npm registry first. Then we will publish it to the blocklet registry. After we have completed the deploy part, I will demo how to do the publish. Okay, it seems the deploy succeed. Let's come back here and see. We have crypto 2048 here. It's not startable now because we have not configured it yet. Let's fill in the required environments here. Let's refresh. Oops, it seems the session has expired. Let me relog in again. Okay, then let's fill in the required environments. The local chain ID is local chain. The foreign chain local chain host is let's copy this for later use. Just change this to 8106. Let's rename this to foreign chain. Okay. Now let's try to start the blocklet. The start process may take some time because the pre-start hook may take some to execute. It's fast on my last testing because I have installed this blocklet before. So if you are waiting for a few minutes, that's reasonable. Then let's open the blocklet. See. Now our my game account has have no game coins. First, we need to do the authorization, so the game can charge me when I start a new game. Then let me buy 100 coins, game coins. And let's wait for the swap complete. Okay. My game coin is charged. Now let's start a new game. And let's try if I can get score up to 1024. That's easy. Okay. Now let me claim this trophy. And confirm. I think that's it. The blockchain game now works in AppNode. Next, let's move on to the publish part. For the publish part, there are few things we need to do. First, we need to update the publish config. For the configuration in package.json, we should put two more attributes. The first one is the publish config, which the most important sub attribute is the directory. As you can see, ABDNode bundle build all files into this subfolder, and it's ignored by Git. And from that folder, we are publishing these files. And ABDNode bundle will also copy these files from the root directory to this directory. So these are required for successful publish. Besides, we should also add a pre-publish hook here in the npm scripts, so that each publish we are publish a new building. We will run bundle and clean up some map files there. And since I have published this package, let's give it a new version. And let me make sure I'm using the right registry. Then let me do publish. The publish part, the npm publish also requires also rebuilds the whole blocklet, both the front end, back end, and the hooks. Okay, seems we are publishing. It's almost there. And after we have published this blocklet to npm registry, the next step is publish to our blocklet registry. Then let's go to the blocklet repo, which is also public, so that you can fork, change, and send pull request here. You can change this file by adding your blocklet. Let me just show you how to do that. You can add a new block by adding its npm registry name. Okay, the publish has done. Let me just change it. And a few minutes later, you will be able to find that blocklet from here. Okay, I think because this workshop has used some open source project or source code. The first one is the 2048 game prototype. We are using one found on CodePen and improved it. And for the trophy SVG, it's downloaded from here. You can check out the link. And I think that's all for this workshop. In this workshop, you have experienced a complete experience from start to finish by building a blockchain game. Now you are familiar with our 4D SDK, our NFT SDK, and some basic design decisions when building a blockchain game that can give you a better user experience. And I can't wait to see your blocklets published to our registry. What are you waiting for? And I'm looking forward you to participate in our hackathon, in which you can build your own blocklet and win our big award. Thank you.
All right. Yeah, that was amazing, right? You really saw it from beginning to end and saw a entire build out with different ArcBlock services. So while it was relatively simple in design, I think what's a good takeaway from that session is it really showcased real features and capabilities of the ArcBlock platform that developers can use right now. You saw decentralized identity, you saw blockchains, blockchain explorer, tokenization. We even added it to our decentralized marketplace on the ABT node, making it available for anyone to use. So it's all real and it's all ready to start using today. Of course, we'll have everything on video and slides for anyone who wasn't able to keep up with the code as we were going along. For anyone who didn't actually have time to do it and you want to try the game, you can simply install the ABT node on your laptop and go to the Blocklet marketplace, and you can install the game right there and start trying it out. For anyone who wants to learn more about ArcBlock, you can simply visit our website, www.arcblock.io. Also, be sure to visit the Devcon website to access all of your different NFT badges that are available. Before we kind of wind down here for this afternoon, I also want to give a big thanks to all of our partners and attendees here at Devcon 2020, AWS, Oro, Docker, Boeing, US State Department, WTIA. We appreciate it, and hopefully it was made for a great experience for everyone. So while the workshops are actually done at this point for today, the activities are actually just getting started for ArcBlock Devcon 2020. At this point, I'm going to go ahead and pass it over to CEO of ArcBlock, Robert Mao, and he's going to give you a quick outline for what is next. So let me go ahead and get him ready here. All right, here we go.
Hey everyone, unbelievably, so our developer conference, most of the session is done. Yeah, thanks a lot for coming, but it's not the end yet because we're going to start our developer conference hackathon immediately from now. And this hackathon is unlike the other hackathon, just need a few days or a weekend, but instead we give 7 days. And in the 7 days, you have a chance to submit a project, organize a team, have an idea, submit a project, and win the hackathon. So before I started, I would like to share some of my stories about the hackathon. So I'm a big fan of the hackathons, and I myself participated into many hackathons before, from attendee. From just attend hackathon, try to organize a team and get nobody excited, and eventually become winning a few of the interesting hackathon. And then ArcBlock, we organize and participate, and even as a team to join the other hackathons in the past few years. So in year 2006, wow, that's 14 years ago. Can you imagine that, right? It's my first time to heard about this word called hackathon, because that time I happened to visit the United States from China. I have a friend in Yahoo, and she invited me. Say, "Hey, Robert, why not come to the Yahoo Hack Day? It's pretty cool, right?" So I came to that Hack Day. So I happened to find a video and about that Hack Day. So basically,
engineering circles, software development circles, hacker actually means someone who builds really great software really fast. Oh, so hackers are good. Then who are the bad guys? Those people.
Did you see who that is? It's me, right? It's interesting that I found when I was hacking there, some journalists were captured, and I even be able to find it today in the YouTube, right? So since that, I realized it's really interesting because if you participate in a hackathon, you not only get a chance to learn new stuff, you basically set your time, a very certain short amount of time for you to try to think out of the box in the hack, because in most of the case in the hackathon you're trying to build something, you're trying to learn something, you're working together with a few other people that you might do not really you probably don't even know them before. Let me just turn this notification off, so it's not going to distribute my video. Sorry. Yeah, so you get to learn new stuff. You build a team. You work with some others. Some of the people I know in the past hackathon event eventually become friends, partners, employees, co-founders. Yes, it's actually opened up a lot of interesting opportunity. So since this Yahoo hackathon, and I actually participated quite a few interesting other hackathons. Notably, I went to South by Southwest hackathon in year 2012, and actually I win big. I win the first prize of the South by Southwest official hackathon, which is a lot of people, and the award prize is huge. I think I win like $20,000 in cash, and $50,000 in the AWS and Windows Azure credit, and a bunch of other perks. And the best is I know a lot of people. I get to know a lot of people, and I get to know the journalists and the news media interviewed on me. So the best is you build up network, you build up a confidence, you understand that you get fitting into this kind of technology environment, which is so cool. And eventually, we end up participate quite a few different hackathons. So this is a photo that I win the hackathon in a Seattle Interactive conference, and during our days in the ArcBlock, we actively participate and sponsor different hackathons. For example, this is one of the hackathons called Hack the Machine. It's a hackathon that is run by the U.S. Navy. Isn't it cool, right? And we become a sponsor, and this is I introduce to them what ArcBlock is, how you can use ArcBlock to win those hackathons with a group of peoples. And we also host our own hackathons. So this is our first ever hackathon happening in Bellevue. That's in our Bellevue office at the time. And there's not a lot of people, and it's only just a half-day hackathon, but we still build quite a few interesting stuff. We learn a lot from the developers who participated in hackathon. And in year 2018, we joined together with TechCrunch China to have this kind of become one of the sponsor and the track in TechCrunch conference, TechCrunch Shenzhen hackathon, and this is the winning team at that time. If you're interested in, if you look at our website, right, under the hackathon tag, you will see we have organized, participate, and joined different hackathons, and quite a few people, they learned ArcBlock, learned the technology, learned something from this kind of hackathon event, which is awesome. Right? So that's the reason why we decided to have a hackathon right after the developer conference. And this hackathon is 7 days long. That basically means it's pretty long time. So you have enough time to digest what you have learned from the developer conference. You're going to have enough time to figure out an idea and get excited on some idea which you want to work on. You also have enough time to find some friends or join some friends team, and or join an existing team if you don't find any other partners, to work on something that is interesting. And so we have very clear rules on this hackathon page. You just come to the DevCon, you come to the hackathon page, and we have the deadline, the time, some ideas to suggest what you want to build. If you don't, in case you don't have the ideas, we have this prize, and the prize could be changing and increasing. If you win that, believe me, that hackathon is actually, even the hackathon is just a few days, but the impact and the value it brings is a long time. Even today, I sometimes in some technical conference, I still bumping with some other guy. Dude, hey, we realize each other. Hey, you are the guys who win that hackathon. Right? You are the guys we team together in that hackathon. So quite a few of them are actually doing pretty good. It's really, it's really the influence of the participating in hackathon. It's going to last for a very long time. It's very valuable. So I myself is I think I benefit a lot from participate and join those hackathons, and it's really valuable. And so it's not just a prize. It's about the fun. It's about building some interesting new stuff. And we also have a few fine prints for those kind of eligibilities, and you probably need to read the rules and to ensure that you're doing it right. For participating in the hackathon, it's pretty simple, and but we have a few kind of judge criteria. So we have the most important thing is originality. We wish you build something that is completely new. The originality doesn't necessarily mean you need to build everything from ground up. You're welcome to remix existing project as long as they allow you to do that. You're welcome to create mashup applications, remix existing stuff, remix some concept, borrow some concept from the other project, but you need to have an originality, which is you're not going to be a copycat, not going to just kind of clone other stuff and change the name. This is not the spirit of the hackathon. The second is creativity. Creativity means basically it also means fun. Right? You need to build something new. You need something fun and let the people feel it's creative. So the hackathon is a great chance for having fun, right? A lot of hackathon projects you will see probably they're not that serious. They could be just a joke, right? But it's a joke that showcases the technology, right? Because it's fun, it's enjoy it, right? And getting inspired from this kind of fun project is really enjoyable, right? Not this kind of boring, projects that last a long time. You get the, let's forget about that. Let's just have fun, do something really creative. And engineering skills, of course, for sure. And if you use, advanced frameworks, if you kind of mash up different technologies together into our platform, then it will be great. So that is also a judge criteria. And of course, the user experience is important. User experience, basically, sometimes when people think about hackers, they might think about a command line, terrible user interface, UI that nobody can understand. But this is not the case. So, so the user experience, easy to use, easy to understand, and fancy, cool, nice looking, all of those, they are the criteria for us to judge, right? So we're going to have some kind of professional judges, and probably during the period of hackathon, we might add in a few more experts into this judge. And remember that all the judges are external, and none of our ArcBlock team is going to become a judge. And one reason why is because actually our ArcBlock team is going to participate in the hackathon. What? We're going to participate? Yes, because we are considering that it's a relatively new platform. So we let our engineers to help other teams to success, right? So feel free to try to grab somebody from ArcBlock to join our team or help you So our rules basically allow us to join the team, help the team, or even if they want, they might be able to build a project to compete, which is so totally okay. But the judge are all outside, so they will decide who is going to win the hackathon. Remember that it's not necessary to be familiar with blockchain with our platform. It's about the idea. It's about the creativity, the originality, and the user experience, right? And we have a few other details, fine prints. I suggest you have a look at that. And to participate, it's pretty simple, right? So we have this GitHub repo called ArcBlock/hackathon Devcon 2020. And to submit your team, you just need to come to the issue and the new issue. Once you knew the issue, you will see we created a template for team submission. You just get started and you fill the blanks into that. So I already created a sample team just here, for example. In this team, you need to give a name for your team or project. You need to write a few descriptions of what the project, what's the idea of the project, what you're going to do. And you provide a GitHub URL here. So we encourage you, open source your Git hackathon project, but it's not necessary. However, to be able to qualify for judging, you will need to at least provide our judge the access to your GitHub repo to ensure that you actually did this during the hackathon time, right? We don't want somebody just to bring something that have worked for months or weeks and then say this is the hackathon, then this is not fair to other teams. And we also do not want you bring some others IP, other property in the code, and they end up have the legal problem for you. So that's why we want you to provide the GitHub URL, but you feel free to close it after the event, after the judge, or you can add our judge secretly into your project so they can just have a look to verify. And all the intelligent properties is going to belong to your team. So you are only authorized ArcBlock to mention you that you participated in the hackathon if you submit, right? And you own all the copyright, everything. And we also need you to ensure that all the code you submitted, there's no IP problem. You basically own and you create all those kind of all those code for in your submission. And we need to have a team member list here. We recommend the hackathon team is no more than 5 members. It's up to 5, right? So each of the members need to put their roles, their ArcBlock's DID. So you can find this DID from your ABD wallet. Find the wallet card with a Devcon 2020 card and use that address. We're going to whoever participating in the project and the project have a runnable project. Remember, it's a runnable project. We're going to give each of the participants some ABD tokens, and the winners will get a lot. And so we will give all the winning stuff to the leaders, and the leaders are going to be in charge of the distribution. And we are also going to give you some NFT certificate or NFT tokens. For example, the book, right? So any of the winners are going to have one of my signed copy of my new book, but the book is not yet available. So what we do is we're going to give you NFT certificate of that you own that book, right? So when the book is ready, we're going to have a website, and you just come to the website and present that token. That token basically means that you own a right of my signed copy of the book, and then that website is going to let you to enter your address so we can mail the book to you. And so this is actually a typical use case of how to use blockchain. Have you to use blockchain tokens, which is in this case, this token is a book, right? So we can immediately give you the book, which is not the real book, but the token of the book, if you win the hackathon. So that's why we need you to have this address, so So we can give that to you. And you can feel free to transfer those tokens to others. If you already, for example, if you already have our premium ticket and you have a book, you win another book and you want to share this book to somebody else, simple. You just send that token to that person, and that person can claim that token with the book, which is pretty good, right? So anybody who win the hackathon, you're going to have a certificate that are winning the hackathon as DID verifiable credential and NFT in your wallet. So we're going to use our blockchain and our block platform for everything, from the winning, from the badge, from anything, right? So which is cool itself. So that's why we need you to leave your wallet DID here. You can have a name here, but it's not necessary, and you can use your nickname, anonymous, or your real name. It doesn't matter. So yeah, so that's pretty much, right? So somebody might ask, what if I need some inspirations, right? So we already have shared a few things in inspiration on the website, but I also shared one of the repo that is internal idea sharing repos inside our blog. You will see we use GitHub to maintain a lot of those ideas. Some of the idea you might say is laughable, it's crazy, it's stupid. Right? It doesn't matter because we record the idea here. And some of the ideas probably just gets inspiration from others. And some of the idea we get from the community when people in the community discussion, hey, what if we have this, that, and we think, oh, this is a great idea. Let's write it down. Right? So we have this repo, and I make this GitHub repo open source, so anybody can submit the ideas. And probably this is if you need some inspiration, feel free to come this DApps idea, ArcBlock DApps ideas to read through them. If you have some ideas you just want to contribute, just put here. No idea is bad idea. So don't feel don't be shy to share anything that you think. Hey, what if I can do this and that? There's no stupid idea at all. So feel free to come here and get some inspirations. Finally, to be able to qualify for the hackathon, you will need to submit the team information, a runnable product, and ideally you also have a pre-recorded video that that demo what you have done before the deadline. We're going to run a live show during the time, but anybody who is a developer knows that sometimes there's something called a demo god. Is basically whenever you do the demo, it's going to break. So it never breaks during my develop time, but once it's demo, it's going to break. Always happen. We understand that. So just to shoot a video, and in case it didn't work, it's not going to work during the demo day, just use a video, and we will forgive that. Everybody in the team, all our judges say they understand the software, what's going on in the software. So have a video, going to be much easier for you to prepare the demo. And there's no PPT need. So one of the important judge criteria, just remember that we need something that is workable. You don't need any PPT, any PowerPoint, any slides, but you do need this project is actually up and running. It could be running with ugly user interface, with bugs and broken here and there, but it needs to be run. It needs to be run. It needs to be live code, real code. The hackathon, the spirit of the hackathon is hacking something. It's not need to be perfect, but it needs to be hacking something. It's not fake. It's not just a concept. So this is the single most important thing. Just remember, you need to get something that is actually working to be able to qualify. So once you have something that is workable and running and it's not copy and clone from others, the team are going to get some award, and hopefully I'm expecting, and we're going to see a lot of interesting projects in this hackathon, and I can't wait to wait that day. So good luck. Hey everyone, unbelievably, so our